Here's a story illustrating that our body has a profounder knowledge of us than we have of our body. Every detail acts as a suggestion we failed to observe.
Fact 1. The heart might initially seem to function with metronome-like rhythm and predictability. However, when a person is hooked up to a sensitive cardiac monitor and the time between beats is closely examined, a peculiar pattern is revealed. The intervals are never the same. A difference of tens of milliseconds is not a fault, but a built-in adaptation. Heart variability, as this is known, is a precise marker of the body's state. High variability signals good fitness, stress tolerance, and well-regulated autonomic nervous system function. Low variability, on the other hand, indicates fatigue, illness, or chronic stress. It's noteworthy that this measure is much higher in newborns than in the elderly. Athletes use it to fine-tune their training, and doctors use it to assess risks. In the 2020s, watches and bracelets started appearing that track variability live. The heart, it turns out, does more than pump blood. It converses with the nervous system, breathing, hormones, and even mood, recording every hiccup in this dialogue before we even know we're getting sick.
Fact 2. An adult human's body consists of about 206 bones, but this count isn't static. It can shift with age, lifestyle, and even unexpected genetic changes. To start, a newborn has close to 100 more bones, around 300. Some of these bones fuse over time. For example, several bones in the skull form a single cap, and the three-part pelvis joins into one strong arch. However, the opposite can also happen. In 2019, anatomists from Flinders University in Australia found that one bone, believed to have disappeared during evolution, the fibula, a tiny bone in the tendon behind the knee, is now appearing more often in people. In the late 19th century, it was found in 1 out of every 10 people, but now it's found in almost 40%. The reasons are still just guesses. Maybe it's because of changes in diet, weight gain, and more pressure on joints. What's more, in some cases, a person might have extra ribs, extra vertebrae, or even 2 atlas bones, the first bone in the neck. This isn't necessarily a sickness. Most people with these extra bones have no problems. So, even the skeleton isn't a fixed pattern, but a flexible architectural plan that can change from one generation to the next.
Fact 3. If the brain were capable of writing memoirs, they would start with silent currents, electrical activity present from the prenatal stage. The first impulses recorded in an embryo occur at the 6th week of pregnancy. However, the significant development happens after birth. In the first year of life, the brain almost doubles in size, not by adding more neurons, but by increasing the connections between them. Every second, between 200 and 1,000 new synapses, connections between nerve cells are created. There are so many that by age 3, a child has nearly twice the number of synapses they will have as an adult. The brain is inherently ready for anything, any language, any culture, any movement. But if these potentials are not utilized, they are removed. This is the process of synaptic pruning, the elimination of weak or unnecessary connections. It's not a decline, but a precise adjustment. By adolescence, the brain stops growing wider and starts to sharpen. Excess is removed, and what's important is strengthened. Everything influences this selection: experience, environment, stress, love, fear. The way we talk, move, solve problems, or recognize faces is the result of our brain choosing to keep one neural network over another during childhood.
Fact 4. From the outside, skin might appear to be a simple covering, but it is, in fact, the body's most substantial and complex system. An adult skin typically weighs around 5 kilograms, surpassing the combined weight of the liver and kidneys. It is organized into 3 distinct layers, each a unique environment. The hypodermis, the innermost layer, functions to store fat and cushion impacts. The dermis, the middle layer, is populated with millions of nerve endings, blood vessels, and hair follicles. The epidermis, the outermost layer, completely regenerates every month. What is most astonishing, however, is the skin's responsiveness. It can signal stress through changes in temperature, increased sweating, and heightened sensitivity. Studies have demonstrated that individuals who receive praise or are touched with benevolent intent experience a temporary increase in their skin's conductivity. It registers emotions and responds to them. In 2022, a team of neurophysiologists from Cambridge concluded that skin possesses the ability to retain short-term sensory input, suggesting the presence of rudimentary sensory memory. Moreover, it produces hormones such as serotonin and vitamin D, transitioning from a passive barrier to an active participant in metabolic processes. Therefore, skin is not merely a protective shield, but an intelligent, communicative fabric that is the first to detect internal changes. Fact 5. The liver stands as the only internal human organ with the capacity for complete regrowth. This is a factual statement, not a metaphor. If as much as 2/3 of its tissue is lost, it initiates a chain of restoration, and within a span of months, it almost entirely regains its mass and functionality. This is not simply the existing cells growing larger, but rather the complete formation of new tissue, complete with blood vessels and its inherent structure. This is why a donor can contribute a portion of their liver to another person, and after 6 months, both individuals will possess an organ that is nearly as it was initially. This ability is directly related to the liver's critical functions. It filters harmful substances, participates in creating proteins, holds reserves of vitamins, controls sugar levels in the blood, and even neutralizes hormones. Each day, it processes over 1.5 liters of blood. The restoration process commences with a rapid activation of genes that were previously in a dormant state. Signaling molecules present in the bloodstream effectively rouse the hepatocytes, which are the liver cells, causing them to begin dividing. It is noteworthy that this progression is systematic. It initially occurs closer to the site where the tissue was lost, and then this wave of regeneration extends deeper. However, the liver does have its limits. Prolonged exposure to toxins, such as from alcohol or viruses, results in the replacement of tissue with scar tissue, thereby blocking the regeneration process. This is where the organ's remarkable power and its inherent fragility are evident, given its round-the-clock operation with virtually no rest. Fact 6. One of the body's most mysterious factories is concealed within the bones: red bone marrow. It is not a brain in the typical understanding, but rather a spongy tissue where millions of blood cells are produced each second. From a single stem cell, an erythrocyte, a platelet, or a lymphocyte can develop based on the body's needs. This process operates under a strict hierarchy: precursor cells, signaling proteins, and regulating molecules. The bone marrow seems to instinctively recognize when a person has a cut and initiates rapid platelet production. Or, upon sensing an infection start, it increases the release of leukocytes. In essence, it functions as the main organ for the immune and blood-producing systems. In babies, all bone marrow is active. In adults, only the marrow in the ribs, sternum, spine, and hip bones remain active. The rest turns into yellow marrow, a layer of fat. In emergencies, this fatty tissue can also become red again, activating backup production. Doctors have long been able to extract bone marrow stem cells for transplants, but they still don't fully understand how and what to produce. It is a system with an internal intelligence, but no nerves. Its control comes not from will, but from an inherent logic of survival. Fact number 7. We rarely consider the daily frequency of our blinking. In fact, it is around 15,000 times. Each blink lasts approximately 0.3 of a second. Over a 24-hour period, this amounts to almost 1.5 hours of blindness, which the brain doesn't typically communicate to our awareness. But why is such frequent blinking necessary? It's not solely for keeping the eyes moist. Blinking acts as a rhythm that guides the visual system's function. Studies have revealed that when we blink, the brain resets its visual areas, discarding superfluous information and cleaning up visual noise. This is particularly important when shifting focus, for instance, from something close to something far, or from a bright environment to a dim one. Blinking can be understood as a punctuation mark, like a semicolon, within the visual stream. Actors delivering monologues tend to blink more slowly. Individuals who are being untruthful blink more rapidly. Moreover, certain neurological disorders can lead to a near absence of blinking, resulting in a diminished ability to perceive changes in one's environment. In 2021, neuroscientists from Japan published research indicating that blinking activates the same brain regions that are engaged during brief rest periods. Consequently, each blink serves not only to protect the cornea, but also as a micropause for the entire nervous system. Our vision is not a continuous stream, but rather a compilation of thousands of short visual segments. Fact 8. Human hearing operates not like a microphone, but as an event analyzer. The ear hears not just sound, but also its source, direction, force, rhythm, and even the likelihood of danger. Everything begins with the tiny eardrum, which is 1/10 of a millimeter thick. It vibrates when air pushes against it and transfers this movement to tiny bones, the hammer, anvil, and stirrup. The stirrup, the smallest bone in the body, is about 3 millimeters long. It pushes the fluid inside the cochlea, a part of the inner ear, where the vibrations turn into nerve impulses. But the real magic happens in the brain. It draws the sound, picks out the important parts, blocks out the extra, and recognizes what is familiar. This is why we can hear our name in a crowd or understand a foreign language if we know its rhythm. Hearing is one of the fastest analyzers. It takes less than 100 milliseconds from a sound to a reaction. The ear also acts as a vestibular center. Inside it are 3 semicircular canals filled with fluid that tell the brain our body's position. If hearing is impaired, it can affect our walk, and if pressure in the ear changes, it can make us feel sick. So, the ear is not just a sound receiver, but a navigation station, a security system, and a noise editor all in one. The 9th fact: saliva is one of the body's most overlooked fluids. We get used to it as background noise, failing to consider that without it, no meal, no spoken word, and not even healthy tooth enamel would be possible. Daily, humans produce between 1.5 to 2 liters of saliva, and its composition shifts dynamically with conversation, influenced by smells, tastes, and emotional states. It is rich in dozens of enzymes, such as alpha amylase, which starts breaking down starch right in the mouth. The level of this enzyme rises significantly when anticipating food or even just thinking about it. Beyond this, there are more intricate functions. Saliva includes antimicrobial proteins like lysozyme, lactoferrin, and peroxidase, which daily combat hundreds of thousands of microbes. A single drop of saliva can host up to 1 million bacteria, but most are harmless. In fact, they contribute to maintaining oral flora. Additionally, saliva is involved in regeneration. It aids wound healing in animals and similarly assists in the healing of the human mucosal membrane. Recent studies indicate that saliva can reveal markers for numerous diseases, ranging from diabetes to cancer, potentially positioning it as a substitute for blood in certain diagnostic tests in the future. Consequently, each act of spitting is akin to sending a chemical telegram containing information about one's bodily condition. Fact 10. The human body is equipped with 2 to 5 million sweat glands, a number greater than that of hair follicles. These glands are present in various locations, with the most concentrated areas being the palms, soles of the feet, and the forehead. Sweat is more than just a simple combination of water and salt. It is a complex fluid containing amino acids, lactic acid, hormones, and, in certain instances, even traces of medications or illicit substances. Its primary purpose is not the elimination of toxins, which occurs to a very limited extent, but rather the regulation of body temperature through cooling. When the body's temperature escalates, the hypothalamus, which serves as the body's thermostat, sends signals to the sweat glands. These glands then release fluid onto the skin surface, and the process of evaporation removes surplus heat. This mechanism is particularly vital during hot weather or periods of physical exertion. It is remarkable that individuals who engage in regular physical training exhibit an earlier onset and a more vigorous rate of perspiration, indicating that their bodies have developed a more efficient method for shedding heat. There are two distinct types of sweat glands: eccrine glands, which are distributed across the majority of the body's surface, and apocrine glands, which are primarily found in the armpits, the groin region, and surrounding the nipples. The latter type becomes active during stressful circumstances and produces a more lipid-rich, aromatic secretion, which subsequently becomes a substrate for bacteria responsible for body odor. Furthermore, perspiration also serves as a means of communication. In the year 2014, a group of researchers from Utrecht made a discovery that sweat from an individual experiencing fear can influence the facial expressions of another person, causing them to contract their facial muscles in a way that mimics apprehension. This suggests that sweat plays a role not only in thermal regulation, but also in conveying messages through nonverbal cues.
The 11th fact: the nose is not simply a passage for air. It functions as a fully equipped biochemical laboratory, a navigational control center, and a protective filtering system. Air, as it travels through the nasal passages, encounters turbulence. These are bony projections that cause the airflow to spin and move in a spiral pattern. This spiral movement provides time for the air to be analyzed and prepared. It gets warmed, dust is filtered out, and it is moistened. The mucous membrane within the nose is covered with millions of microscopic hairs and a layer of mucus that is only hundreds of a millimeter thick. This is where bacteria, viruses, and particles of dirt get deposited. Crucially, the sense of smell is also located here. The olfactory receptors are positioned high up, near the base of the skull, and they form a direct connection with the brain's limbic system, which is the center for emotions and memory. This is why smells can trigger such vivid recollections. The same fragrance can bring back feelings of childhood, a sense of worry, or the emotion of being in love, depending on the specific context. The nose also contains neurons that are sensitive to pheromones and other chemical signals, although these are less prominent in humans than in animals. Nevertheless, they are sufficient for us to intuitively sense our own versus others. Moreover, the nose plays a role in regulating voice resonance. When the nose is congested, the voice sounds different. In essence, the nose is not just a guardian of our breathing, but a sophisticated mediator between our body and the world around us.
Fact 12. Digestion begins much earlier than the stomach, and even before swallowing. When a person sees food or thinks about it, the brain starts a chain of signals. Salivary glands get activated, the stomach starts releasing acid, and the pancreas prepares enzymes. This is the conditioned reflex stage of digestion, discovered by Ivan Pavlov in the 1800s. The second stage is mechanical. Swallowing is a complex, highly coordinated action. Over 30 muscles work together to move food from the throat to the esophagus, avoiding the windpipe. In the esophagus, food is moved by peristalsis, regular contractions that push food down, even if a person eats while lying down. In the stomach, proteins start breaking down. Hydrochloric acid and pepsin turn the solid food into chyme, a semi-liquid paste. After 2 to 3 hours, it moves to the small intestine, where pancreatic enzymes and bile begin their work. Absorption starts here too. The intestinal walls have villi and microvilli that increase the surface area to the size of a tennis court. This is the main point of exchange. Through the intestines, the body gets energy, building materials, and vitamins. And if anything goes wrong, everything is affected. Digestion is not just eating and digesting, but a very complex symphony, where the smallest problem with one instrument changes the whole tune. Fact 13. Muscles are not solely about strength. They are a universal system for movement, heat, metabolism, and even hormonal response. The human body has over 600 muscles, and almost everyone is multifunctional. The largest is the gluteal muscle. The fastest is responsible for blinking, and the most enduring is the heart muscle. Crucially, it is their interaction. Even a simple act like raising an arm requires the coordinated work of dozens of muscles. Some contract, others relax, and still others stabilize. Inside a muscle fiber are thousands of myofibrils, made of actin and myosin filaments. These slide past each other like zipper teeth, creating contraction. But nothing happens without an electrical impulse. A nerve transmits a signal and the muscle responds. This connection is so fast that an athlete can react to a starting sound in fractions of a second. During training, a muscle doesn't just grow larger. It increases its number of nuclei, develops capillaries, and enhances receptor sensitivity. Muscles are also an endocrine organ. During exertion, they release myokines, proteins that affect immunity, mood, and even the growth of new neurons. Therefore, physical activity is not just a way to burn calories, but also a form of molecular communication. Every movement is not just an effort, but a message to the body. I am alive, I am ready.
Fact 14. The eyes are the only portion of the brain that is brought outside the body. Their design is nearly an engineering miracle. The iris, which regulates the passage of light, is similar to a camera's diaphragm. The pupil is not an opening but a responsive filter. It narrows to 1 millimeter in bright light and widens to 8 millimeters in dim light. The lens is a living lens that changes its shape when instructed by the ciliary muscles. But the most crucial element is the retina. It is a very thin film at the bottom of the eye, containing around 130 million photoreceptors, cones and rods. Cones are responsible for seeing color in the light, and rods are responsible for seeing in black and white in dim light. It is surprising that on 1 square millimeter of the yellow spot, which is the center of vision, the density of cones is greater than in the best sensors. Every photon that enters the eye causes a series of chemical reactions that eventually become an electrical impulse. However, the brain does not just get a picture, it puts it together, understands it, and adds to it. This is why a person sees a whole scene, even though the eye constantly moves and jumps, and a part of the field of vision is blind because the optic nerve exits there. Additionally, the retina is a reflection of one's health. Diabetes, high blood pressure, and tumors can be diagnosed by looking at it. This is because it is the only place in the body where blood vessels can be seen directly without any operation. The eye is not a window to the world. It is a screen, an editor, and a mirror of the body all at the same time. Fact 15. Skin responds to cold, the brain to pain, and hair to emotions. While hair itself is dead tissue, its root, the follicle, is alive, complex, and sensitive to hormones, stress, and light. An adult person has approximately 5 million hair follicles, with each functioning as a mini factory. On the head, there are about 100,000 follicles. Hair growth occurs in distinct phases: anagen, the active growth phase; catagen, the transitional phase; and telogen, the resting phase. This cyclical pattern leads to the effect of hair loss, as about 10% of head hair is in the resting stage at any given moment. Stress, illnesses, or restrictive diets can substantially increase this percentage, resulting in what is called seasonal shedding. The most astonishing feature, however, is hair's reaction to emotions. The sensation of goosebumps and the erection of hair are caused by the contraction of a small muscle, the erector pili, which is attached to the follicle. This is an ancient reflex inherited from our ancestors. In animals, it serves to make their fur thicker when facing danger or cold. In humans, it persists as an echo, causing hair to stand on end due to fear, excitement, or music. Additionally, hair functions as an archive. Its structure can reveal the hormones and toxins a person has absorbed over the past few months. Studies conducted on pilots, athletes, and prisoners have confirmed that cortisol levels, the stress hormone, are precisely recorded within the hair, similar to how tree rings mark the passage of time. These silent strands on our head are a record of our emotions, nutrition, and environment.
Fact 16. The immune system is not one organ, but a widespread army equipped with memory, a set of regulations, and internal surveillance. Millions of cells circulate within the blood and tissues, each specialized for its particular task. Lymphocytes, macrophages, dendritic cells, and neutrophils all have distinct responsibilities to identify, destroy, remember, and signal. However, precision is the most critical factor. The body must be able to tell its own components from foreign ones. If the system malfunctions, it leads to either autoimmune diseases, where the body attacks itself, or cancer, when it fails to recognize danger. Lymphocytes are educated in specific organs: B lymphocytes in the bone marrow and T lymphocytes in the thymus. This organ is especially important during childhood, but atrophies as one gets older. Scientists first understood its importance in the 1960s, when removing the thymus from mice resulted in a complete immune system breakdown. The lymphatic system is another vital element. It collects excess fluid from tissues, filters it in the lymph nodes, and returns it to the bloodstream. It is within the lymph nodes that antigens and defensive cells encounter each other. The memory of the immune system is not an abstract concept. After encountering a virus, B lymphocytes keep information about it for years, allowing them to react immediately upon reinvasion. This is how vaccinations operate. Immunity is not armor, but rather an early warning and rapid response network. It is molecular intelligence with a lifelong memory. Fact 17. The human intestine is longer than it seems. Its total length is approximately 7 meters, with the small intestine making up nearly 6 meters of that. This is not simply a tube, but a living, sensitive, and independent system. It has its own nerve network, the so-called enteric brain, which has up to 500 million neurons. This is more neurons than are in the spinal cord. It is this system that coordinates wall contractions, enzyme secretion, and interaction with microbes. Most importantly, it does this on its own. The intestine can contract and digest even if a person is unconscious. It can learn after operations, diets, or changes in its microflora. The clearest signals we feel are rumblings, spasms, hunger, and sometimes butterflies in the stomach. All of these are signs of the enteric nervous system working. It is directly connected to the brain through the vagus nerve, and scientists are increasingly talking about the gut-brain axis. Emotions affect digestion, and the state of the gut affects mood. A study in 2013 from UCLA showed that after a course of probiotics, participants' emotional perception improved, and brain activity changed in the areas responsible for stress. This means the intestine is not just an organ for absorbing food, but a full participant in the psychophysiological orchestra. It is the second brain, but with primary consequences. Fact 18. Blood is not just a liquid. It is a multifaceted system. It operates as a transport mechanism, an immune defense, a temperature regulator, and an emergency response system. An adult human body contains approximately 5 liters of blood. Plasma makes up about half of this volume, consisting of water, proteins, glucose, hormones, and salts. The rest is made up of cells. These include erythrocytes, which transport oxygen, leukocytes, the body's immune sentinels, and thrombocytes, which repair blood vessels. Erythrocytes are the most prevalent, with up to 5 million found in a single cubic millimeter. Their absence of a nucleus allows them to flex and navigate through capillaries as narrow as 2 to 3 micrometers. These cells typically last for about 4 months before being processed by the liver and spleen. The bone marrow produces around 200 billion new erythrocytes each day. Leukocytes are produced less frequently, but have longer lifespans and diverse functions. Thrombocytes, conversely, live for only a week, during which they continuously patrol the vessels. When damage occurs, they quickly adhere to the wound's edge, activate a series of proteins, and create a clot. Blood also controls body temperature by moving heat from muscles to the skin, facilitating cooling. Additionally, it carries hormones, metabolic waste, and inflammatory signals. If an infection begins, blood rapidly delivers markers to initiate a response. It is more than just the river of life that ancient culture spoke of. It is a mobile, swift, self-regulating biological fleet where every component is aware of its route and its specific job. Fact 19th. Sleep is not a deactivation. It is a shift in operational mode, a maintenance cycle, and, to a significant extent, a personal system refresh. On average, individuals spend a third of their lives sleeping, amounting to approximately 25 years. Within this time frame, processes take place that are impossible to initiate while awake. Sleep is categorized into two phases: slow-wave sleep and rapid eye movement, REM sleep. During slow-wave sleep, the body undergoes restoration. Body temperature declines, respiration rate decreases, growth hormones are activated, and the brain undergoes cleansing. A study conducted in Rochester in 2012 revealed that at night, the brain activates the glymphatic system. This system comprises a network of channels responsible for expelling metabolic byproducts, including toxic proteins linked to neurodegenerative diseases. This cleansing process is contingent upon sleep. REM sleep is the phase associated with dreaming. In this stage, nearly the entire brain is active, yet the body remains paralyzed to prevent physical movement during sleep. During this phase, memory consolidation occurs, neural pathways are reinforced, and events are processed. A reduction in REM sleep, such as that resulting from chronic sleep deprivation, leads to a decline in emotional regulation and creative cognitive functions. Furthermore, sleep serves as a rehearsal ground for reactions. The brain simulates significant moments, potential threats, and future scenarios. Consequently, sleep is not merely a period of rest. It is a nocturnal laboratory where the brain evaluates reality, rectifies impairments, and revises its own operational script. Fact 20. Fingers are the ultimate expression of motor skills. No other species can match the precision, speed, and range of motion found in human fingers. Each finger contains 3 segments, along with a network of ligaments, tendons, nerves, and blood vessels. Notably, the muscles that control finger movement are situated in the forearm, not within the fingers themselves, and they operate via long tendon cords. This structure imparts a sense of lightness and flexibility. The thumb holds a special significance. Its capacity to move in opposition to the other fingers is essential for activities such as gripping, writing, and playing instruments. Each finger is connected to a distinct region of the brain. The sensory motor cortex features a body map where the fingers occupy an unusually large area. For pianists and seamstresses, these areas are even more expanded, reflecting the brain's adaptation to intensive training. The touch receptors on the fingertips are exceptionally sensitive, capable of detecting minute variations in texture down to 1/10 of a millimeter. Beyond touch and movement, fingers are integral to communication, from basic counting to complex gesturing. For deaf individuals, fingers are the foundation of their language. Moreover, fingers carry a person's signature. Finger movements can reveal identity with a 90% accuracy. Therefore, each finger is not merely bone and skin. It is a nexus of memory, coordination, language, and precision. Fingers are an evolutionary tool that has literally allowed us to take control of our world. Fact 21. Body temperature is a figure that signifies a highly sensitive balancing act. The internal temperature of a human is approximately 36 6/10 degrees Celsius. This is an average, and throughout a 24-hour period, the temperature can shift by 1 degree. It is lower in the morning and higher in the evening. Women have their own temperature patterns corresponding to different stages of their cycle. During sleep, the body's temperature decreases, and during stress, it increases. The hypothalamus, a small part of the brain about the size of a cherry but with substantial control, manages this. It gets signals from temperature sensors in the skin, internal organs, and blood. If the temperature drops, the body starts to shiver, blood vessels narrow, and the skin becomes pale. If the temperature rises, blood vessels widen and sweating begins. These are not reactions to the external environment, but rather attempts to maintain internal steadiness. Even a change of 1.5 degrees can affect how enzymes work, how the brain functions, and metabolism. A fever is also a form of regulation. When an infection occurs, the body intentionally raises its temperature to slow down the growth of germs. However, during heat stroke or chilling, these control systems can fail, making every degree potentially dangerous. Temperature is not merely a number shown on a thermometer. It is a form of communication from the body about its state of equilibrium or its loss of it. Fact 22nd. A voice functions as a unique personal signature, a musical instrument, and a signaling mechanism simultaneously. Its origin is in the larynx, not the mouth, where two vocal folds, which are delicate muscular flaps, vibrate when air is pushed through them. The frequency of these vibrations, from 80 to 1000 Hz, dictates the sound's pitch. Men typically have longer and thicker vocal folds, leading to a lower voice. Women's folds are shorter and thinner. Children's folds are short and weak, producing a high and ringing timbre. However, the vibration itself is not the complete voice. The sound is altered by resonators, the throat, the nasal cavity, the mouth, and the sinuses. The position of the tongue, lips, and jaw all play a role in the timbre, volume, and intonation. The brain is the control hub. Broca's area is for building sentences, Wernicke's area is for understanding, and the motor cortex is for controlling movements. It is fascinating that a voice changes not only with age or illness, but also with one's mood. When anxious, the voice gets higher. When tired, it becomes muffled, and when happy, it gains richer overtones. Moreover, a voice reflects breathing status, hormonal levels, and even blood sugar. Modern neural networks can now detect Parkinson's disease, depression, and diabetes by analyzing voice. Therefore, every sound spoken is not merely information, but a biometric signal that can reveal a full diagnosis. Fact 23rd. The strongest part of the body is the teeth. Their enamel is harder than steel and can withstand hundreds of kilograms of pressure. However, a tooth is a living structure. Inside it is pulp, containing vessels, nerves, and connective tissue. This is not just a pain conduit, but the tooth's life center. Teeth develop long before they appear. Milk teeth from the 6th week in the womb, permanent teeth from birth, but hid. Each person has a unique dental passport: shape, position, bite, microcracks. Forensic experts can identify a person with amazing accuracy by their teeth. It's surprising that teeth react not only to food and hygiene, but also to stress. Under chronic tension, people unknowingly clench their jaws or grind their teeth in their sleep, bruxism. This leads to enamel wear, microcracks, neck pain, and even headaches. Another detail is that teeth cannot heal. Unlike bones, they don't regenerate. Damaged enamel doesn't recover. So, a cavity isn't just a hole, but an irreversible loss. Still, teeth have a powerful resource. Modern studies show that tooth condition can reveal vitamin deficiencies, stomach diseases, and even the risk of heart problems. A smile isn't just about looks, it's a report on how the whole body is working. Fact 24th. Memory is not a static shelf within the brain. It's a dynamic process occurring through movement, involving chemistry, electricity, and the passage of time. We have short-term memory, which lasts for seconds and minutes, operating in the frontal lobes and sustained by an active neural network. Then there's long-term memory, found in the temporal lobes, particularly within the hippocampus. This intricate organ, resembling a seahorse in its coiled shape, is responsible for converting temporary information into permanent storage. This conversion requires sleep, repetition, and emotional engagement. Information is absorbed less effectively without emotional input. Adrenaline and dopamine enhance memorization, explaining why we better recall significant events. Moreover, memory functions as an editor rather than a storage unit. Each instance of recalling something involves a slight modification of that memory, akin to editing a file. Consequently, memories evolve over time, becoming distorted by the influence of new information. Motor memory also exists, referring to movements that become ingrained in the body, such as riding a bicycle or playing a musical instrument. While difficult to articulate verbally, the body retains this knowledge. Emotional memory is also present, acting associatively, where a particular smell or sound can evoke a memory. Researchers continue to debate the precise location of memory within the brain. However, it is evident that memory is not confined to a single area, but is distributed across the entire cerebral cortex, organized into intricate patterns. Memory is not an archive, but a living network that expands, functions, loses, and reestablishes connections. Within this network lies more information than we are capable of recalling. Fact 25th. Reaction time is among the most accurate reflections of an organism's condition. On average, the period from the eye perceiving a flash to the finger activating a button is around 250 milliseconds. This duration is a product of the integrated functioning of several systems: visual, neural, and motor. Light strikes the retina, is converted into an electrical signal, which then proceeds along the optic nerve to the brain's occipital region. From there, the signal is passed to the frontal cortex for a decision, and then routed through the spinal cord to the muscles. Any impediment in this sequence results in a delayed reaction. For individuals with extensive training, such as professional racers or esports players, their reaction time can be less than 160 milliseconds. Conversely, for those who are fatigued, under the influence of alcohol, or unwell, it may exceed 400 milliseconds. It is noteworthy that responses to auditory stimuli are generally faster than to visual ones, owing to a more direct path from the ear to the brain. Pain perception is the slowest, as the signal must first reach the thalamus, be filtered, and be imbued with emotional content. In clinical practice, reaction time serves as an indicator of cognitive health, and in athletic contexts, as a measure of readiness. This represents a rare instance where the brain, muscles, and emotions function in perfect harmony. And when you brake on a highway, it is not merely a reflex. It is a swift orchestration of critical decisions, accomplished in fractions of a second. Fact 26th. The scalp is a unique ecosystem. It's thinner than skin on other body parts, filled with blood vessels, and contains up to 100,000 hair follicles. Each follicle connects to a sebaceous gland that produces sebum. This sebum protects hair and prevents moisture loss. But the balance is easily disrupted. Excess sebum causes inflammation, dandruff, and itching. Lack of sebum results in dryness and hair brittleness. Scalp cells renew every 3 to 4 weeks. However, if the microflora is imbalanced, this process becomes disordered. Hundreds of bacteria and fungi live on the scalp, including Malassea, a yeast-like fungus that, when overactive, causes seborrheic dermatitis. Interestingly, this microflora reacts to hormones, stress, and diet. Stress can increase sebum production. Vitamin deficiencies slow hair growth. The scalp also helps regulate body temperature. In heat, blood vessels expand to release heat, causing increased sweating. In the 2020s, trichology, the science of scalp and hair, has been developing quickly. Research shows that the condition of this area affects both appearance and overall well-being. Scalp massage, it appears, is not just enjoyable. It improves microcirculation, impacts cortisol levels, and can even enhance sleep quality. The scalp is more than just a place for hair. It's a regulator, a mirror, and a sensor all in one. Fact 27th. The skeleton is not merely a supporting structure. It functions as a manufacturing plant, an information archive, and an alert system. For adults, the skeleton makes up around 15% of body mass and consists of 206 bones. It's important to understand that bones are not dead material. Inside them, construction is constantly happening. Osteoblasts build, osteoclasts break down, and osteocytes manage these activities. A full skeleton renewal cycle takes about 10 years. Every bone is encased in the periosteum, a sensitive membrane with blood vessels and nerves. This is why injuries to bones cause pain. Inside the larger bones is bone marrow, where blood cells are produced. Bones also act as a reserve for calcium and phosphorus. If there's a deficit, the body takes these from the bones, and if there's an excess, it stores them. However, if this balance is disturbed, osteoporosis develops. The skeleton is also involved in endocrine regulation. In 2007, osteocalcin was discovered, a hormone released by bone tissue. It impacts glucose metabolism, testosterone, and even memory. Another surprising fact is that bones are sensory organs. They have nerve endings inside that can respond to pressure and load. Therefore, moderate physical activity strengthens the skeleton, while inactivity weakens it. This means bones are not just a framework, they are an active, living system that sensitively responds to movement, diet, hormones, and even mood. Fact 28. The tongue is an organ of remarkable complexity. It is made up of 8 muscles that are not attached to bones, which makes it the most mobile organ in the body. It plays a role in speech, chewing, swallowing, and, of course, in tasting. Its surface is covered with thousands of taste buds, and each taste bud contains up to 100 receptor cells. These cells are capable of distinguishing 5 basic tastes: sweet, salty, sour, bitter, and umami, which is a savory, rich flavor that was discovered relatively recently. The notion that different areas of the tongue are responsible for specific tastes is a myth. Every part of the tongue can detect all tastes, but with varying degrees of intensity. In addition to taste, the tongue analyzes temperature, texture, and spiciness. It contains some of the most sensitive receptors. The tongue is constantly renewing itself. Taste cells have a lifespan of about 10 days. The tongue also serves as an indicator of one's health status. White coating, cracks, or changes in its shape can all be signs of illness, a lack of vitamins, or digestive problems. Moreover, the tongue has its own unique fingerprint. Its shape, folds, and mobility are unique. In Eastern medicine, diagnosing health through the tongue is a recognized discipline, and modern dentists use 3D tongue scanning as a biometric tool. It is interesting to note that the tongue forms sounds but not by itself. It works together with the palate, lips, and larynx. It is not merely a piece of muscle. It is an instrument for speech, taste, emotions, and health. Fact 29th. Sweat glands operate beyond just hot conditions. They engage during stress, anxiety, pain, and even moments of unexpected joy. This phenomenon is termed emotional sweat. Apocrine glands, concentrated in the armpits and groin, secrete a substance that is more viscous and fatty compared to eccrine glands, which are uniformly distributed across the body. It is the apocrine glands that contribute to body odor, as their secretion is rapidly utilized by bacteria residing on the skin. Consequently, an individual body scent emerges, so unique that dogs can identify people even after extended periods of absence based solely on a t-shirt. Notably, within romantic relationships, couples frequently select partners whose scent exhibits significant differences in certain major histocompatibility complex proteins, potentially enhancing the immune robustness of their offspring. In experimental settings, women were presented with men's t-shirts to smell and asked to select the most pleasant scent, and the preference was most often for a genetically compatible yet not identical scent profile. This suggests that sweat glands serve purposes beyond mere bodily cooling. They are involved in communication, mate choice, and identification. Their activity is more closely tied to context than to climate. A crucial meeting, an examination, feelings of fear or embarrassment, and the body instantly conveys this information to those around. It is a nonverbal language discernible by the wet trace on the temple. Fact 30th. Tears are not simply water exiting the eyes. Their composition is a complex mixture comprising water, salts, proteins, lipids, hormones, and even trace amounts of neuropeptides. There are 3 kinds of tears: basal, which constantly moisten the eye, reflex, produced when the eye is irritated, and emotional. It is the emotional tears that attract the most interest. Emotional tears emerge not only during sadness, but also during intense joy, pain, or relief. They differ in their composition, containing more stress hormones such as adrenocorticotropic hormone and prolactin. This means that crying is not merely a reaction, but a method for the body to release tension. It is interesting that tears do not flow in all mammals during emotions. Dogs and cats only cry from physical irritation. Human tears, however, have become part of social communication. Studies show that a face covered in tears is perceived by others as more honest, vulnerable, and likely to elicit sympathy. But there is also a downside. In some individuals, tears are blocked under stress conditions as the body enters a state of hypercontrol. This can lead to psychological blockages. Tears are not a weakness, but a physiological reboot. Their composition is a biochemical diary of experiences. They wash away not only dust from the eyes, but also some of what has accumulated inside. Fact 31st. The navel, a small depression on the stomach that we grow accustomed to from childhood, is actually an important trace of a large system that operated before birth. Through the umbilical cord, the fetus received oxygen, nutrients, and immune bodies, and in return, it expelled carbon dioxide and metabolic products. Inside it are two arteries and one vein, surrounded by a jelly-like tissue called Wharton's jelly, which protected the vessels from kinks. After birth, the umbilical cord is clamped and cut, stopping blood flow. The body then begins processes of separation. The heart and lungs start working independently, and the liver and kidneys take over filtration. However, traces of the umbilical cord remain, in the liver as a round ligament and in the bladder as a median ligament. The navel itself is a skin and scar formation, and it is unique to everyone. Studies of naval microflora have shown that dozens of types of bacteria can live on it, including ones not found anywhere else on the body. Some people have a forest ecosystem, while others have a sea one. This depends on hygiene, clothing, climate zone, and even profession. Historically, the navel was an object of mysticism, a symbol, and even a fashion item. But most importantly, it reminds us that each of us was part of another body. And this scar is not just a mark, it is the first point of connection with life. Fact 32nd. The pharynx acts as a junction for the respiratory and digestive tracts. It connects the nasal and oral cavities to the larynx and the esophagus. Each time we swallow, our body executes a fine-tuned coordination. The epiglottis, a cartilaginous flap, closes the opening to the trachea, preventing food from entering the airways. This process, taking mere fractions of a second, is governed by many nerves and muscles. Any disruption can lead to choking. It is interesting that the human larynx is positioned higher than in most mammals. This allows for a wide range of vocalizations, but also makes us more susceptible to choking. In infants, the larynx is even higher, allowing them to suck and breathe simultaneously. It moves lower as they grow. During speech and singing, the epiglottis functions like a conductor, directing airflow, shaping sound, and protecting the airway. In the case of vomiting, the entire system operates in reverse. Muscle contractions move upwards, the diaphragm pushes from below, and the pharynx opens to expel contents. The pharynx is one of the rare body regions where voluntary control and automatic processes intersect. We can initiate swallowing voluntarily, but its completion is entirely automatic. This demonstrates how the body, at the nexus of crucial life functions, resolves tasks in real time, hundreds of times daily without error, almost always. Fact 33rd. Tendons act as the body's ropes. They connect muscles to bones, transmit force, and can handle loads of hundreds of kilograms. The most robust are the Achilles tendons, linking the calf muscles to the heel bone. They can withstand a force of several tons before breaking, yet they remain elastic. When a person jumps, tendons store elastic energy and then release it, boosting the push. This makes movement efficient. For a runner, up to half of their energy comes from the tendon's recoil, not just muscles. Tendons themselves are made of collagen fibers lined up in parallel bundles and are covered by a sheath with synovial fluid for easy gliding. But unlike muscles, tendons get very little blood. This means their recovery after injuries is slow and tricky. Tendinitis, which is tendon inflammation, is a common problem for both athletes and office workers. Too much strain, small injuries, and not enough rest, and the structure starts to break down. What's quite interesting is that tendons can remember the load. For people who train, they get thicker and stronger. For people who don't move much, they get weaker. Modern medicine is creating ways to help tendons grow, from using ultrasound to giving biological injections. This is because these hidden threads are crucial for every step, every lift, and every touch. Fact 34th. The cerebellum, long believed to be just a movement coordinator, has in the 21st century been found to be involved in speech, attention, learning, and even emotions. Its structure is similar to a head of cauliflower. It is dense, folded, and symmetrical. It contains over half of all brain neurons, though it occupies only 10% of the brain's volume. Its primary job is precision. It receives copies of all signals that the brain sends to muscles, compares them with the actual outcome, and makes corrections. Thus, damage to the cerebellum causes tremors, unsteadiness, and slowed movements. But it also has cognitive functions. Children with cerebellar impairment show difficulties with speech and writing. Adults experience problems with switching attention, predicting events, and the sense of time. The cerebellum is like an internal metronome, a rhythm keeper, an editor. In 2019, neuroimaging studies showed its activity when solving logic problems and expressing emotions. It turned out that it participates in managing the smoothness not only of movements but also of thoughts. And this is not surprising, because thoughts are also a kind of movement, just an internal one. The cerebellum is an invisible conductor that, without us noticing, keeps the tempo, rhythm, and clarity in everything we do or think. The 35th fact. Hormones act as the body's molecular messengers. They are produced in internal secretion glands, enter the blood, and affect tissues, sometimes located thousands of kilometers away. Some hormones work like accelerators, adrenaline, thyroxine. Others like brakes, for example, melatonin. There are burst hormones, like oxytocin, released upon touch and during childbirth. And there are background hormones, like insulin, regulating sugar levels. It is surprising that the same hormone can cause different effects depending on the tissue. Adrenaline in the heart speeds up the pulse. In the skin, narrows blood vessels. In the liver, releases glucose. The hormonal system operates on the principle of feedback. If a hormone level increases, the pituitary gland reduces the signal for its production. If it drops, it strengthens it. This allows for maintaining balance. Disturbances lead to dramatic consequences. Excess cortisol to insomnia and obesity. A deficit of thyroid hormones to sluggishness and swelling. And sex hormones, estrogen and testosterone, influence not only reproduction but also memory, mood, and behavior. Modern endocrinology considers hormones as universal regulators. They do not give orders but suggest, amplifying or weakening signals. And the entire life of the organism is a symphony, where hormones set the tonality for every phrase, every action, every sensation. Fact 36th. Lymph is an unseen but vital river in the body. It flows in its own vessels, parallel to veins, serving as a channel for cleaning, transport, and immune oversight. Every day, roughly 2 liters of fluid pass through the lymphatic system. It collects excess water, proteins, cell remnants, bacteria, and even cancer cells from tissues, moving them to lymph nodes for filtering. Lymph nodes are key immune outposts where macrophages and lymphocytes check every bit of cargo, destroying harmful elements. If a node gets overloaded, it swells and can hurt. Lymph moves slowly, without a heart, pushed by muscle contractions and breathing pressure. This is why inactivity causes swelling. Lymph gets stuck. The lymphatic system is unique because it's a closed loop, but not completely sealed. Lymph can leave vessels and return. In the brain, a special glymphatic system cleans tissues while you sleep. Problems with lymph flow can lead to lymphedema, a persistent and difficult-to-fix swelling. Yet, lymph is a promising area for medicine. It can be used to deliver drugs, diagnose illnesses, and manage inflammation. It's not a second bloodstream as people used to think, but a separate network that's closely connected. It's like a silent guard watching over the entire body. Fact 37. The gut microbiome is an invisible civilization residing within us, affecting every health dimension, from digestion to mood. Trillions of microorganisms, bacteria, fungi, viruses, live on the walls of the small and large intestines, their collective genome being 100 times ours. These tiny inhabitants process complex carbohydrates and fiber, create vitamins B and K, and play a role in how medications work. Significantly, they communicate with us. Through the intestinal mucous membrane, microorganisms release signaling molecules, short-chain fatty acids, indoles, bilavates, which enter the bloodstream and impact immunity, metabolism, and general well-being. For example, butyrate, formed from fiber fermentation, nourishes the intestinal lining cells, strengthens the gut barrier, and reduces inflammation. The development of dysbiosis, a microbial imbalance, is linked to numerous diseases, such as irritable bowel syndrome, obesity, autoimmune conditions, and depression. Gut bacteria can change the production of neurotransmitters. Serotonin, dopamine, and gamma-aminobutyric acid are synthesized not only in the brain, but also in the gut, and their deficiency leads to mood alterations. Scientists have even demonstrated that fecal microbiota transplants from happy individuals to anxious ones decrease anxiety symptoms in mice. The microbiome is more than just a passenger. It's a fine-tuned regulator of our internal physiological processes. In the future, it's possible we will treat illnesses by adjusting our invisible universe rather than solely with pills. Fact 38. Brown adipose tissue is a hidden source of heat and energy, a characteristic that has persisted in humans since the time of our ancestors who lived in cold climates. Different from white fat, which serves as insulation and a calorie reserve, brown fat cells are abundant in mitochondria and are densely supplied with blood vessels. When temperatures drop, they become active through the sympathetic nervous system, initiating the oxidation of fatty acids and glycogen. Instead of producing ATP, this process generates pure heat, a phenomenon called thermogenesis. Newborns have the highest concentration of brown tissue in their neck and shoulder areas, but adults also retain enough to make a significant contribution to maintaining body temperature. Recent studies have revealed that lean individuals have more active brown fat than overweight individuals, which could affect their risk of developing metabolic diseases. Interestingly, moderate intake of cold water, regular walks in cold weather, and diets rich in capsaicin and caffeine can stimulate the awakening of brown tissue reserves. The thermogenic cells within it can even reprogram some white fat, transforming it into a type similar to brown fat known as beige fat. This occurrence presents promising possibilities for treating obesity and type 2 diabetes, not solely through diet and physical activity, but also by activating the body's internal energy generator. Brown adipose tissue functions as a quiet engine that can convert cold into improved health and extended longevity. Fact 39. Within the core of every cell resides an organelle that, for the past 50 years, was not recognized as an independent being. The mitochondrion. It functions akin to a small power plant, possessing two membranes, the inner one folded into cristae, where adenosine triphosphate, the body's energy currency for all reactions, is produced. However, the mitochondrion is not simply a reactor. It carries its own DNA, inherited solely from the maternal line, and contains up to 2,500 genes that direct not only energy output, but also cellular signaling, apoptosis, the process of programmed cell death, and even thermal regulation. As far back as 1962, Lynn Margulis proposed the endosymbiotic hypothesis, suggesting that an ancient bacterium entered a cell, leading to the formation of the mitochondrion. This was confirmed by the similarity of their genomes to bacterial ones, a discovery that revolutionized the understanding of eukaryotic life's origins. Nevertheless, mitochondria are not uniform. A sprinter's muscle cells may contain twice the number found in an average individual, and neurons even more, given that the brain requires up to 20% of the body's total energy while comprising only 2% of its mass. Impairments in mitochondrial function result in a range of mitochondrial spectrum diseases, manifesting as muscle weakness, kidney and liver dysfunction, cardiac issues, and neurological impairments. One of the most seldom forms is Lee syndrome, initially described in 1974, where the buildup of lactic acid in the brain causes seizures and vision loss. Yet, there is an unexpected turn. Mitochondria play a role in modulating the immune response. When attacked by a virus, they change their shape, release protective signaling molecules, and initiate inflammation. In 2025, scientists from the Albert Einstein Institute discovered that mitochondrial DNA, expelled from a cell under stress, can act as an alert, activating macrophages and lymphocytes in lymph nodes. It appears these tiny power stations are not merely fuel depots, but living communication links between energy metabolism, cell death, and the body's defense mechanisms. Their legacy from ancient bacteria continues to resonate in every heartbeat and every thought.
Fact 40. The brain's neural wave patterns contain a specialized cleaning mechanism known as the glymphatic system, identified in 2012 by scientists from the University of Rochester School of Medicine. It operates as a fine network of channels facilitating the exchange between cerebral spinal fluid and interstitial fluid, thereby removing metabolic waste products like beta amyloid, tau proteins, excess calcium, and toxic compounds. During sleep, especially deep, slow-wave sleep, brain capillaries dilate, and the space between neurons expands by 30%, allowing alien molecules to be flushed out through perivascular pathways. This mechanism is crucial for preventing neurodegeneration. In 2018, neurophysiologists at Harvard Medical School proved that mice with experimentally disrupted glymphatic systems quickly accumulated beta amyloid plaques, indicative of Alzheimer's disease. An experiment detailed in Nature Neuroscience revealed that a 20% increase in sleep depth achieved through audiovisual stimulation enhanced glymphatic system efficiency by 30% in human subjects. This system also plays a role in other brain processes, such as the distribution of medications, particularly large molecules, within the brain, suggesting potential for more effective therapies for tumors and neuropathies. Furthermore, discoveries in the 2000s established a link between glymphatic system issues and migraines. Morning pain and a feeling of mental cloudiness could stem from the accumulation of metabolic byproducts in the extracellular space. Consequently, our brain not only processes information, but also regularly purges digital waste to maintain cognitive clarity. This inherent order is fundamental to sustained mental health and longevity.
Fact 41. Osteoporosis is a quiet bone destroyer that might not show itself until a minor fall causes a fracture. The skeleton of an adult human is replaced every 10 years. This renewal involves osteoblasts, which construct new mineral matrix, and osteoclasts, which dismantle the old matrix. Typically, these processes are in equilibrium. However, with aging and hormonal shifts, the equilibrium favors resorption. This is particularly evident in women post-menopause. Reduced estrogen levels double osteoclast activity, resulting in an annual bone mass loss of up to 5%. Osteoporosis diagnosis is based on densitometry. The method of dual-energy X-ray absorptometry, DEXA, first utilized at the University of Copenhagen Clinic in 1985, is a key technique. It measures the density of the hip and lumbar spine, detecting a decrease in mineral content even when 15% has been lost. Unexpected factors also play a role. A study from 2020 at the University of Toronto revealed that regular physical activity, including vigorous uphill walking and not just running or strength training, stimulates bone tissue development. This activity boosts bone density by 7% over 6 months. Another significant discovery concerns vitamin K2. French scientists in 1993 found that vitamin K2 activates osteocalcin, a hormone produced by bone tissue, thereby improving calcium binding. A vertebral or hip fracture in an elderly individual is a serious warning, increasing the one-year mortality risk by 30%. Therefore, osteoporosis prevention and early detection are vital public health issues. Treatment encompasses not only calcium and vitamin D, but also drugs that modify osteoclast activity, such as bisphosphonates and denosumab. Ultimately, the skeleton is an adaptable and durable system, but without continuous physical demand and hormonal support, it can become a source of weakness and risk.
Fact 42. The skeleton's role extends beyond structural support. It also acts as a calcium reservoir, regulating blood calcium levels. When blood calcium ions fall, parathyroid glands secrete parathormone. This hormone signals osteoclasts, bone cells, to release minerals from the bone. However, sustained stimulation leads to structural deterioration, causing bones to lose density and become porous. Intriguingly, the human body possesses a bone remodeling with memory mechanism. A study from the University of Cambridge in 2020 revealed that areas subjected to mechanical stress retain increased density even after the stress is removed. In contrast, dead zones, like the base of the skull, become more fragile with age. The skeleton is also a dynamic entity. Small bones in the hands and feet contain up to 45% of the body's small osteokomata vessels, crucial for tissue microcirculation. These vessels feed parasites, which control the formation of new bone tissue in response to microdamage, tiny cracks that occur with every step or movement. This phenomenon was identified in 1988 at the Orthopedics Institute of Lund University. An unexpected function of the skeleton is its involvement in endocrine regulation. Osteocalcin, a hormone originating from the bone matrix, influences not only bone density, but also the pancreas, stimulating insulin production and male reproductive health by improving sperm motility. This establishes a feedback system where bones contribute to regulating carbohydrate metabolism and reproductive well-being. Consequently, our skeleton is not merely a framework, but an active endocrine and sensory organ that senses loads, remembers them, and communicates adaptation needs to other bodily systems.
Fact 43. The thymus, also referred to as the thymus gland, stands as one of the most mysterious organs within the immune system. It is located behind the sternum and reaches its peak size by the age of 2 years. Following this, it gradually shrinks, transforming into fatty tissue by the time an individual is 20 years old. However, the thymus plays its most critical role during childhood. It is within this gland that T lymphocytes, the fundamental cells of cellular immunity, are educated. The gland possesses a complex internal structure divided into cortical and medullary zones by a basal membrane. In the cortical region, immature T cells undergo a rigorous selection process. They are equipped with receptors that enable them to recognize foreign antigens while simultaneously ignoring the body's own molecules. If this selection process fails, autoimmunity arises, leading to cells attacking the body's own tissues. It is noteworthy that the thymus can decrease in size when subjected to stress, infections, or even radiation, which temporarily weakens the immune system. Nevertheless, after the removal of the stressor, the gland regains its original size and function, as if drawing upon internal reserves. Experiments conducted on mice have demonstrated that the introduction of cytokines, such as interleukin-7, can stimulate the regeneration of an atrophied thymus and restore its structural organization. This finding opens up possibilities for therapeutic approaches to address age-related immune system weakening. Therefore, the thymus is not simply a remnant of a young body, but a dynamic center that substantially impacts the ability to fight infections and maintain health throughout one's life.
Fact 44. The pancreas acts as a dual executive, managing both digestion and endocrine control. Positioned deep inside the abdominal cavity, it is composed of two main sections.
The exocrine section creates pancreatic juice, which breaks down proteins, fats, and carbohydrates. The endocrine section is made up of the islets of Langerhans. Each islet contains several kinds of cells. Alpha cells make glucagon, which boosts blood sugar. Beta cells release insulin, which lowers sugar and allows cells to take in glucose. Delta cells secrete somatostatin, which controls the release from surrounding cells. And PP cells produce pancreatic polypeptide, which regulates appetite and the digestive system's movement. The balance between these hormones is fragile. When beta cells are overworked due to constant high blood sugar, they can become exhausted, leading to type 2 diabetes. Type 1 diabetes develops when the immune system attacks beta cells. The islets are not spread evenly. They constitute roughly 1.5 to 3% of the gland's total mass, but their hormonal effects are felt throughout the body. Insulin influences how fats and proteins are processed and controls cell growth, while glucagon serves as the body's energy store. In laboratory settings, islet transplants are employed for diabetes treatment, but their effectiveness is still limited because of rejection issues and the need for immunosuppression. The pancreas is an organ with two engines, and both must operate together smoothly for us to digest food and maintain consistent energy levels. Fact 45th. The spleen functions as an invisible filter for blood and a repository for immune reserves. This organ, weighing about 150 grams, is divided into two areas: the red pulp, venous sinusoids, and the white pulp, lymphoid follicles. Within the red pulp, blood flow slows, allowing macrophages to engulf old red blood cells, and platelet reserves are ready to be mobilized during bleeding events. The white pulp contains aggregations of T and B lymphocytes, which, upon encountering antigens, synthesize antibodies and initiate cell-mediated responses. Under normal conditions, the spleen holds up to 30% of all platelets and a significant quantity of lymphocytes, releasing them in urgent situations. When the spleen is removed, splenectomy, for instance, due to trauma, the risk of bacterial infections, particularly pneumococcal infections, increases, necessitating vaccination and antibiotic prophylaxis for lifelong protection. The spleen's unique ability is its capacity to expand and contract. It enlarges when there's a greater demand for blood cleansing and shrinks when the demand lessens, adapting to hemodynamics. In fetuses, it plays a role in blood creation until the bone marrow forms, and in adults, it remains a vital reserve for immune cells. Thus, the spleen is not merely a filter organ, but a dynamic immune-based and a blood quality control center. Fact 46th. Nails are durable keratin plates that grow at a speed of about 3 millimeters per month, and each one records our lifestyle. Underneath the nail plate is the nail root, found below the cuticle. This is the site where new cells are created, filled with keratin. The speed of their division is affected by nutrition, hormonal status, and overall well-being. A lack of vitamin B, iron, or thyroid conditions can lead to slower growth and brittle nails. The nail's color shows how well blood is circulating and the condition of the heart and blood vessels. A pink color means good oxygen supply. Paleness or a bluish tint might indicate anemia or issues with blood flow. Crosswise grooves on the nail surface can be seen after a fever or intense stress, while lengthwise lines often appear with age. White spots, marks, and damage signs are the result of small injuries to the root and growth area. Worn edges and hangnails suggest dry skin and a lack of essential fatty acids. It's noteworthy that nails can heal after being hurt, provided the lunula and root are not damaged. In criminal investigations, microscopic traces on the nail plate can sometimes be used to identify a person. Nails are not merely decorative. They serve as a live monitoring system for the body's internal processes and an external display of our habits, from diet to stress, imprinted in their slow growth pattern. Fact 47th. Lungs are not simply breathing bags. They are a massive biofilter and a gas exchange site covering an area the size of a tennis court. The total surface area of alveoli, the tiny sacs where bronchi end, reaches up to 70 square meters. Each breath supplies oxygen to a thin network of capillaries. An alveolus has a wall only half a micron thick, allowing gas to pass through in fractions of a second. Upon birth, lungs are filled with air for the first time, an event marked by the release of surfactant, a special substance preventing alveoli collapse during exhalation. John Nichols first described this lung surfactant emulsifier in 1963, a discovery that saved thousands of premature infants. Lungs process up to 12,000 liters of air daily, trapping dust, allergens, and microbes via the cilia of bronchioles and mucus that flows down to the throat. Macrophages in the alveolar sacs silently consume incoming particles. During physical exertion, the volume of air moved per minute can increase 20-fold, maintaining balanced airflow, and the lungs adapt instantly. They manage not only oxygen and carbon dioxide levels, but also the blood's acid-base equilibrium, a critical aspect of homeostasis.
Fact 48. Blood vessels are a widespread network spanning hundreds of thousands of kilometers in the body, serving as a crucial life pathway. Arteries deliver blood from the heart under significant pressure. For instance, the aorta can tolerate pressures of up to 160 millimeters of mercury and circulates roughly 15 liters per minute during physical activity. Its elasticity comes from elastic fibers found by Edward Berlin in 1922, which help to moderate pulse waves. Following this, arteries split into arterioles and capillaries with diameters of 6 to 8 micrometers. Through these tiny vessels, red blood cells pass one at a time, squeezing through and offloading oxygen to the tissues. The total length of capillaries is estimated at 80,000 kilometers, which is enough to go around the Earth's equator twice. Venules and veins return blood to the heart, and valves in the veins prevent the blood from flowing back, particularly in the legs when standing. Any problems, such as blood stagnation or the formation of clots, can lead to serious health issues, from varicose veins to pulmonary embolism. Doctors measure pulse pressure and the cross-sectional area of blood vessels to assess the risk of developing high blood pressure and atherosclerosis. The vascular endothelium, which forms the inner lining of arteries and veins, produces nitric oxide, the key regulator of vessel tone, discovered by Robert Furchtgott and Farid Murad in 1980s. This intricate system essentially dictates how each cell in the body functions.
Fact 49th. The blood-brain barrier serves as an invisible shield between the bloodstream and the delicate central nervous system. Documented in 1909 by Edwin Goltman and Paul Ehrenheim, it is formed by specialized endothelial cells in capillaries, joined by tight junctions maintained by brain astrocytes. These junctions effectively stop toxic compounds, microorganisms, and nearly all external molecules, allowing passage only for glucose, amino acids, and vital lipids. The barrier is dynamic, with transport regulated by carriers and pumps acting as biomechanical gateways. Inflammation or injury can drastically increase its permeability, resulting in brain edema and neurological symptoms. The central nervous system lacks a conventional lymphatic system, but the recently discovered glymphatic network within perivascular spaces collaborates with the barrier to improve the clearance of metabolic waste from deep brain areas. The development of drugs that can penetrate this barrier is a significant challenge of our time. To treat tumors or adjust neurochemical processes, molecules that appear as natural carriers are required. Fact 50. Cartilage tissue functions as a resilient padding between bones, cushioning impacts and allowing joints to move silently. The human body features three kinds of cartilage: hyaline cartilage, which coats the bone ends within joints; elastic cartilage, located in the ears and larynx; and fibrous cartilage, found in the discs between vertebrae and in symphyses. Hyaline cartilage, a component of the synovial joint surface, is composed of chondrocytes situated in an acellular matrix made of type II collagen and proteoglycans that hold water. This arrangement provides hydrodynamic elasticity. When squeezed, fluid is expelled, creating additional resistance, and when released, it flows back, much like a sponge. Synovial fluid, termed synovia, supplies nutrients to the cartilage and reduces friction during movement. Its chemical properties and thickness are managed by synoviocytes on the inner surface of the joint capsule. In osteoarthritis, wear and tear leads to the destruction of hyaline cartilage, causing inflammation and the joint's inability to absorb shocks. Regenerating cartilage is difficult because it does not have a blood supply. So doctors employ cell therapy, such as implanting artificially cultivated chondrocytes or introducing stem cells that are guided to differentiate. This is a progressive area of regenerative medicine where successful outcomes rely on accurate biochemistry and mechanical stimulation of cells. Cartilage is not merely padding, but a complex, smart lubrication system, without which walking would become painful and noisy.
Fact 51. The endoplasmic reticulum, an extraordinary transport complex, resides within every cell of our body. It is structured as a network of flat channels and vesicles, enveloping the nucleus and pervading the entire cytoplasmic space, much like a city subway network. The endoplasmic reticulum is divided into two distinct areas. The rough endoplasmic reticulum, characterized by attached ribosomes where protein synthesis occurs, and the smooth endoplasmic reticulum, lacking ribosomes, which is involved in the production of lipids, steroid hormones, and the detoxification of toxins. Liver cell enzymes originate within the membranes of the rough ER, ensuring that the vascular supply of every organ receives a clean metabolic product. Its most significant role is as a quality control mechanism. After proteins are assembled in the rough ER sections, they fold into specific spatial configurations that determine their function. A mistake triggers a reticulum stress alert. The cell either activates its chaperone system to repair the protein structure or initiates apoptosis, a programmed cell death pathway to prevent defective proteins from potentially causing tumors. Therefore, each cell meticulously examines thousands of proteins daily, and only those folded correctly are forwarded to the Golgi apparatus. Here, they receive carbohydrate postmarks and are then transported along internal routes to their destinations, such as membranes, lysosomes, or secretion outside the cell. The endoplasmic reticulum functions not just as a manufacturing site, but as a center for oversight and regulation. During viral infections, the reticulum activates autophagy, a process of self-degradation of cellular components to eliminate viral proteins. In situations of lipid excess, such as with obesity, it expands its smooth compartments to process fat. Consequently, this intracellular network acts as the principal conductor of cellular metabolic processes and a molecular barometer of health.
Fact 52nd. The small intestine is the longest and most complex part of the digestive tract, measuring about 6 meters. It is divided into 3 sections: the duodenum, the jejunum, and the ileum. It is responsible for the chemical breakdown of food, with pancreatic enzymes and bile emulsifying fats, and peptidases breaking down proteins, as well as for the fine absorption of nutrients such as amino acids, fatty acids, glucose, vitamins, and mineral salts. The mucous membrane of the small intestine is covered with millions of villi and microvilli, increasing the absorption surface area to the size of a tennis court. Enterocyte cells actively transport substances across the membrane using the sodium-potassium pump and specific transporters. Pathologies like celiac disease, which is gluten intolerance, impair this function by causing the immune system to damage the villi, reducing the overall absorption area and leading to nutrient deficiencies. The small intestine also acts as a barrier against microbes. Mucus secreted by goblet cells forms a protective layer, and Peyer's patches, which are collections of lymphoid tissue where T and B lymphocytes monitor antigens, are present in the lumen. Upon encountering pathogens, local immunity is activated, and the secretion of immunoglobulin A into the intestinal lumen suppresses the growth of harmful bacteria. Therefore, the small intestine functions as a giant digestive laboratory, a biochemical filter, and an immune garrison, where precise absorption and protection mechanisms work together to ensure our nutrition and health. Fact 53rd. The neurotransmitter serotonin, referred to as the molecule of happiness, is a principal regulator for many bodily functions, such as mood, sleep, blood vessel tension, and the operation of the digestive tract. A significant point is that around 95% of serotonin in an adult's body is generated not in the brain, but within the enterochromaffin cells of the small and large intestines. Within these cells, the amino acid tryptophan is converted by the enzyme tryptophan hydroxylase into 5-hydroxytryptamine, which subsequently undergoes decarboxylation to form active serotonin. A portion of these molecules enters the bloodstream and impacts vascular tone. During hypotension, they cause arteries to constrict, thereby raising blood pressure. The main role, however, is paracrine. Serotonin governs intestinal motility, stimulating peristalsis and the secretion of fluid. An excess of serotonin results in diarrhea, whereas a deficit leads to constipation. In the brain, serotonin is produced in the Raphe nuclei of the pons and is distributed through the upper and lower Raphe pathways to the cortex, limbic system, and brainstem structures. In these locations, it operates through 7 receptor types, influencing mood, sleep, appetite, and the perception of pain. Antidepressants classified as selective serotonin reuptake inhibitors, SSRIs, impede the SERT transporter, leading to an elevated concentration of serotonin in the synaptic cleft and the restoration of normal signal transmission. Consequently, serotonin functions not merely as a joy hormone, but as a comprehensive mediator that connects the digestive, vascular, and nervous systems. It illustrates the direct influence of intestinal metabolism on brain function and how an imbalance in one system can affect the health of the entire organism. Fact 54th. The enzyme ATP synthase is fundamental to all cellular respiration reactions. It is a substantial protein complex built into the mitochondrial membrane. This complex features a rotating and a static module, forming a molecular turbine. The proton gradient created by the electron transport chain causes the rotor to spin. This rotational mechanical energy is then applied to synthesize adenosine triphosphate, ATP, from adenosine diphosphate and phosphate. Each ATP synthase molecule comprises over 20 subunits organized into 2 principal domains, F0 and F1. The F0 subdomain forms a channel allowing protons to move from the intermembrane space into the matrix. The F1 domain is a spherical part where ATP is synthesized at 3 catalytic sites. A single ATP synthase molecule can produce as many as 100 ATP molecules every second, providing energy for muscle contractions, neuronal function, and all active transport processes. Problems with this enzyme's operation lead to serious mitochondrial myopathies. For example, mutations in genes that code for F0 subunits cause Naegeli breakage syndrome, a congenital tissue hypoxia characterized by abnormal muscle and heart development. Thus, ATP synthase serves not only as a biochemical catalyst, but as a cellular microturbo power station, converting mechanical rotation at the nanoscale into energy that sustains the entire organism, from a simple blink to vigorous running. The 55th fact. Each second, the human body produces thousands of new proteins, serving as enzymes, signals, and structural components for cells. Before they become active, every polypeptide goes through post-translational modification. This process, called glycosylation, involves the endoplasmic reticulum and Golgi apparatus attaching carbohydrate chains to the polypeptide. These oligosaccharide bracelets decide the protein's future, its destination, how long it stays in membranes, and how it interacts with others. Different parts of the Golgi apparatus add specific tags. For example, one part adds mannose phosphate to send proteins to lysosomes, while another adds N-acetylglucosamine for release outside the cell. If the sugar sequence is wrong, the protein gets stuck, causing stress in the endoplasmic reticulum and potentially leading to genetic lysosomal pathway disorders like Gaucher disease or Tay-Sachs disease. It's interesting that glycocode variety is more than just simple markers. On immune cells, oligosaccharides form a passport that T lymphocytes and macrophages use to recognize the body's own tissues. During embryonic development, the cell's glycoprint changes, and this signal tells cells to move, specialize, and form organs. So the carbohydrate shell of proteins isn't just decoration, it's a code that controls how all the body's cells move, exchange materials, and interact.
Fact 56. Erythrocytes, which are red blood cells, have an average lifespan of 120 days and are anucleated to maximize space for hemoglobin. However, without their life's passport, they would be unable to join the systemic circulation. Specialized oligosaccharide structures, known as SNACsers, develop on the surface of mature cells, and their composition changes with age. Macrophages in the spleen and liver read this code. When N-acetylgalactosamine is more abundant than galactose on the erythrocyte's membrane, it signals for phagocytosis. Disruptions to this mechanism, such as an autoimmune hemolytic anemia, lead to premature cell destruction. It is interesting that before being eliminated, an erythrocyte passes through the spleen's narrowest capillaries, losing membrane sections and gaining age-related tags. Only after a series of physical tests does it reach the macrophage processing site. This identification check protects the body from the accumulation of aged cells and liberates iron for the creation of new erythrocytes. From hemoglobin, macrophages synthesize bilirubin, which the liver then converts into bile pigments, playing a role in fat digestion. Therefore, the life of an erythrocyte is not merely oxygen delivery, but a sophisticated cycle involving labeling, filtration, and reprocessing, underpinned by dozens of physical and biochemical mechanisms. Fact 57. The blinking reflex is governed by a sophisticated multi-tiered circuit. Irritation, such as pollen or intense light, is detected by corneal receptors, which then transmit a signal via the trigeminal nerve to the nuclei of the pons in the brain. From there, motor commands are immediately dispatched. The facial nerve stimulates the eye's closing muscle, resulting in eyelid closure within 200 milliseconds. At the same time, other bodily structures are activated. The brainstem coordinates the synchronized contraction of the circular mouth muscle and neck muscles, offering protection to both vision and the airways. While this system operates automatically, it can be consciously controlled, for instance, by using willpower to keep the eyes open. When conditions like multiple sclerosis or head trauma occur, this circuit is interrupted. The visual cortex fails to transmit the command, leading to asymmetrical blinking, which medical professionals use for diagnostic purposes. It is noteworthy that individuals with high emotional intelligence tend to alter their involuntary blinking frequency according to the context. Blinking slows during text reading and accelerates when viewing faces, optimizing the processing of visual information. Consequently, blinking is not solely a protective reflex for the eyes, but an integral part of a complex sensory motor loop aimed at maximizing perceptual accuracy and ensuring the body's safety. Fact 58. The human circadian rhythm is regulated by the master clock located in the suprachiasmatic nucleus, SCN, of the hypothalamus. Within the SCN cells, genes clock, BMAL1, and PER are expressed daily, and melatonin is synthesized, forming a 24-hour cycle at the molecular level. Light entering the retina influences the SCN's activity through the retinohypothalamic tract, suppressing melatonin release during the day and allowing it at night. In addition to the central hypothalamic clock, there are local oscillators in the liver, heart, adipose tissue, and skin. These peripheral clocks receive signals from the SCN but can also adapt to changes in diet and temperature. Dysynchronosis occurs when time zones are changed or night shifts are worked, causing central and peripheral rhythms to diverge. This leads to sleep disturbances, metabolic issues, and impaired immunity.
In the long term, jet lag is associated with an increased risk of metabolic syndromes and cancer. Scientists are developing chronobiological drugs to synchronize peripheral clocks, such as agomelatine, which acts on melatonin receptors. This indicates that our body is not a single entity, but rather an orchestra of many biological metronomes, whose harmony determines our health, energy, and longevity.
Fact 59th. The kidneys serve as more than simple filters. They are a complex arrangement of glandular capillaries and tubules. This system is crucial for maintaining homeostasis, regulating water, electrolytes, and the acid-base balance. Each kidney contains approximately 1 million nephrons, which are the basic structural and functional units. Each nephron is composed of the glomerulus, Bowman's capsule, and a tubular system. Blood enters the kidney via the renal artery at a rate of about 1,200 milliliters per minute. Of this amount, roughly 200 milliliters are filtered through the capillary walls into the capsule. The filtrate, which is plasma ultrafiltrate without proteins, moves through the proximal convoluted tubules, then the thin loop of Henle. In the loop of Henle, the osmotic gradient and the differing permeability of the ascending and descending limbs result in urine concentration. After this, the filtrate passes through the distal tubules and collecting ducts. Within the collecting ducts, the permeability of the membranes is modified by the antidiuretic hormone vasopressin, which regulates the volume of water excreted. When blood pressure decreases, the adrenal glands release renin, initiating the renin-angiotensin-aldosterone system. Angiotensin II constricts blood vessels and stimulates the adrenal cortex to produce aldosterone. Aldosterone enhances the reabsorption of sodium and water in the distal tubules, thereby increasing blood volume and pressure. At the same time, the cells of the juxtaglomerular apparatus respond to reduced blood flow by secreting renin, and the macula densa responds to the concentration of chloride ions in the urine. Therefore, kidneys are not passive filters, but an endocrine organ with feedback, maintaining the body's internal resources by responding to the slightest fluctuations.
Fact 60. The urinary bladder functions as a container for urine. Its volume and form are influenced by the detrusor muscle's tone, which constitutes the bladder wall, and by the synchronized action of nerve centers in both the spinal cord and the brain. When the bladder accumulates 150 to 200 milliliters of urine, the stretching of its walls triggers mechanoreceptors. These receptors transmit signals via the pelvic nerves to spinal cord segments S2 to S4, and subsequently to the micturition control centers located in the pons. Here, the urine parcel is registered, and if the social context is appropriate, a command is issued to relax the external urethral sphincter and contract the detrusor. The process of urination comprises distinct phases: accumulation, storage, activation, and voiding. Each phase is meticulously regulated by the parasympathetic and sympathetic branches of the autonomic nervous system. In patients experiencing spinal cord damage at levels above S2, these phases become disrupted, potentially leading to a neurogenic bladder characterized by either incontinence or retention. Chemical mediators such as acetylcholine at the neuromuscular synapses induce detrusor contraction. Conversely, norepinephrine, acting through beta-3 adrenoreceptors, causes detrusor relaxation during the accumulation phase. Clinically, for overactive bladder conditions, muscarinic receptor antagonists like oxybutynin are administered to reduce the frequency of urges. For neurogenic disorders, sacral root electrical stimulation is a potential therapeutic option. The bladder is not simply a receptacle for waste products, but a dynamic organ whose coordinated operation is crucial for maintaining a satisfactory quality of life and effective social functioning.
Fact 61. The adrenal glands are paired endocrine glands found on the upper parts of the kidneys. They are made up of a cortical layer and a medullary layer, with each part carrying out specific roles. The cortex is divided into 3 zones: the outer zona glomerulosa, which makes mineralocorticoids, aldosterone, that controls sodium and potassium balance; the middle zona fasciculata, which creates glucocorticoids, cortisol, that impact carbohydrate metabolism, immunity, and how the body reacts to stress;
and the inner zona reticularis, which produces sex steroids, androgens. The adrenal medulla is made of modified nerve cells and produces catecholamines, epinephrine, and norepinephrine. These are released into the blood when the sympathetic nervous system is stimulated, leading to a faster heart rate, wider airways, and the release of stored sugar. The production of corticosteroids is managed by a negative feedback system. The hypothalamus releases corticotropin-releasing hormone, CRH, which tells the pituitary gland to make adrenocorticotropic hormone, ACTH, and ACTH then tells the adrenal cortex what to do. Too much cortisol and aldosterone stops the release of more CRH and ACTH. Problems with the adrenal glands include an enlarged cortex in Conn syndrome and a lack of function in Addison's disease. Addison's disease happens when the immune system attacks the cortex, causing a shortage of cortisol and aldosterone, which leads to darker skin, low blood pressure, and problems with body salts. The adrenal glands are more than just a shield over the kidneys. They are a busy endocrine factory that handles the fight-or-flight response, keeps body fluids and salts in balance, and helps with sexual development during teenage years.
Fact 62nd. The pineal gland, also called the epiphysis, is a small, cone-shaped organ located centrally in the brain. It weighs about 100 milligrams and is responsible for producing melatonin and regulating circadian rhythms. Pinealocytes, the cells of the epiphysis, receive light information from the retinohypothalamic tract. Light stimuli reach the pineal body via the suprachiasmatic nucleus in the hypothalamus and the dorsal raphe pathway. As light levels drop at sunset, the epiphysis increases the production of melatonin from serotonin, a process involving the enzymes N-acetyltransferase and hydroxyindole O-methyltransferase. Melatonin acts as a potential antioxidant, an immunomodulator, and a signal for sleep, informing the body that nighttime has begun. It binds to MT1 and MT2 receptors in the hypothalamus and other tissues, controlling sleep phase, sleep intensity, and the depth of slow-wave sleep. With advancing age, the epiphysis's activity diminishes, which can lead to reduced sleep quality in older individuals and disruptions in their circadian rhythms. In medical practice, external melatonin and its agonists, such as agomelatine, are used to address sleep disorders and restore the brain's internal clock. Furthermore, the pineal gland plays a role in regulating several hormonal axes, affecting the reproductive cycle through its interaction with the hypothalamic pituitary system. Thus, the epiphysis is more than just a time beacon. It is an integrator of light signals and a biochemical conductor of the body's daily rhythms.
Fact 63rd. The thyroid gland is a small but highly effective organ shaped like a butterfly and located at the front of the neck. Despite its minimal mass of approximately 20 grams, it produces thyroxine and triiodothyronine hormones. These hormones are crucial for regulating metabolic rate, tissue growth, brain development, and heart activity. The process involves follicle cells capturing iodine from the blood, combining it with tyrosine, and synthesizing hormone precursors. These precursors are subsequently broken down and released into the circulatory system. The rate of these processes is managed by specific transporter proteins and the thyroid-stimulating hormones secreted by the pituitary gland. An overproduction of hormones leads to increased heat generation, an elevated heart rate, and accelerated metabolic functions, a condition known as hyperthyroidism. Conversely, a deficiency in hormones results in slowed metabolic reactions, a decrease in body temperature, and the onset of fatigue, depressive states, and weight gain. It is remarkable that the thyroid gland possesses adaptive capabilities. When iodine supply is low, it enlarges to form a goiter, enhancing its ability to absorb this vital micronutrient. In autoimmune conditions, termed thyroiditis, the body's immune system mistakenly attacks the thyroid follicles, impairing hormone synthesis. The 20th century saw the introduction of radioactive iodine therapy. This treatment selectively eliminates hyperactive cells, with subsequent management of the remaining tissue through medication. Thyroid hormones exert influence not only on the metabolism of proteins, fats, and carbohydrates, but also on the nervous system's performance.
They enhance receptor sensitivity to neurotransmitters, are involved in the myelination of nerve fibers during childhood, and regulate the reflex responses of the spinal cord. Insufficient thyroid hormone levels during prenatal development cause congenital cretinism, a severe condition marked by impaired growth and intellectual development. Consequently, the thyroid gland functions not merely as an engine booster, but as a sophisticated regulator that synchronizes the body's internal clock, impacting temperature, weight, mood, and even the body's response to stress.
Fact 64th. The parathyroid glands are four small 2 to 3 millimeter discs found on the posterior side of the thyroid gland. They are responsible for producing parathyroid hormone, the key regulator of calcium and phosphorus levels in blood and bones. When blood calcium ion levels fall, chemoreceptor cells quickly increase hormone secretion. This hormone encourages minerals to be released from bones, calcium to be reabsorbed by the kidneys, and vitamin D to be activated from inactive forms in the kidneys. This mechanism rapidly restores normal ion levels, which are necessary for muscle contractions, blood clotting, and nerve signal transmission. Overactivity of the parathyroid glands results in hyperparathyroidism, where excess calcium leaves the bones and enters the blood, potentially causing kidney stones and osteoporosis. A deficiency in the hormone, known as hypoparathyroidism, leads to bones becoming excessively dense, while muscles and the nervous system experience spasms, cramps, and paresthesias. It is interesting that when there is a chronic shortage of vitamin D, the receptors on parathyroid cells become more sensitive, attempting to maintain homeostasis, but this happens by drawing from bone reserves. Conversely, excessive use of synthetic vitamin D analogs can suppress parathyroid hormone secretion and lead to a risk of hypocalcemia. Parathyroid function is an example of perfect feedback, where minor shifts in biochemical markers are swiftly corrected by a messenger hormone acting at a distance from its source.
Fact 65th. Specialized structures in the skin, known as mechanoreceptors, enable the perception of touch, pressure, vibration, and texture. Meissner's corpuscles are located close to the epidermis in the papillary layer of the dermis and respond to light touches and low-frequency vibrations. Pacinian corpuscles, which are large, concentric, layered formations deep in the hypodermis, are highly sensitive to high-frequency oscillations and firm pressure. Merkel's discs, found as expansions in the basal epidermal layer, are responsible for recognizing sustained pressure and object shape, which is vital for grasping. Ruffini endings, which are branched terminal structures within the dermis, register skin stretching and alterations in joint position. All these corpuscles are connected to the tactile pathways that extend to the spinal cord. Nerve fibers collect signals and relay them to the thalamus, and then onward to the somatosensory cortex, where a body map is developed. Beyond their sensory functions, the activation of these receptors prompts the release of neuropeptides that influence the state of blood vessels and immune cells in the skin. Touch initiates the renewal of the epidermis, mitigates inflammation, and lowers cortisol levels. It is remarkable that with prolonged exposure to identical vibrations, receptors adapt, causing one to cease feeling clothing on the body. Yet, sensory perception can be reinstated at any moment by changing the stimulus. In people who are deprived of tactile contact, such as in states of sensory deprivation, emotional well-being and cognitive functions rapidly decline. Consequently, skin mechanoreceptors are not merely sensors, but active participants in maintaining homeostasis and regulating emotions. They convey to the brain information not only about the shape and force of touch, but also its emotional context, whether it is pleasure, pain, or anxiety.
Fact 66th. The creation of vitamin D involves several stages. It begins in the skin due to exposure to ultraviolet B radiation. The substance 7-dehydrocholesterol, present in the epidermal basal layer cells, changes into pre-vitamin D3, pre-B cholecalciferol, when rays hit it. This then naturally transforms into vitamin D3, cholecalciferol. After this, the liver processes it by adding a hydroxyl group, making it 25-hydroxyvitamin D.
The kidneys then add another hydroxyl group, creating the active form 1,25-dihydroxyvitamin D, or calcitriol. Calcitriol connects to receptors inside the intestinal cells. This action boosts the creation of proteins that are essential for moving calcium and phosphate ions through the intestinal wall. As a result, more minerals are absorbed from what is eaten. Calcitriol also influences bone tissue by encouraging osteoblasts and, indirectly, osteoclasts. This action helps keep the process of bone renewal in balance. A shortage of vitamin D occurs when there isn't enough sunlight or when the hydroxylation process is faulty, as in liver or kidney illnesses. For children, this shortage leads to rickets, a condition where bones harden slowly and the skeleton gets misshapen. For adults, it results in osteomalacia, characterized by soft bones and muscle discomfort. It's remarkable that vitamin D also influences the immune system. Calcitriol reduces the making of inflammatory compounds and makes the protective layers of the airway lining stronger. Therefore, vitamin D is not merely a sun vitamin, but a substance with hormone-like effects. It creates a connection between the skin, liver, kidneys, bones, and the immune system, forming a unified system that supports the health and sturdiness of the skeleton.
Fact 67th. Underneath the liver lies the gallbladder, a small, pear-shaped container. It concentrates and stores up to 70 milliliters of bile, which is made by hepatocytes. After food intake, particularly fatty foods, cholecystokinin, a hormone from the duodenum's eye cells, makes the gallbladder's muscle contract. This pushes concentrated bile into the common bile duct. In this duct, bilirubin, cholesterol, and bile salts break down fat into smaller droplets, increasing their surface area. This helps lipases break triglycerides into fatty acids and monoglycerides more effectively. If there isn't enough bile, like with choledocholithiasis or gallbladder dyskinesia, fats are hard to digest. Unmelted cholesterol can form crystals and stones. This can cause gallbladder pain, biliary colic, and a greater chance of gallbladder inflammation, cholecystitis. It's noteworthy that bile salts in the gallbladder can be reused more than 20 times before going back to the intestine and then the liver, saving the body's resources. So, this small sac acts as a collector and dispenser, controlling the fat part of digestion and keeping lipid metabolism stable.
Fascia, a type of connective tissue, creates a continuous, three-dimensional web that encases each muscle, blood vessel, nerve, and organ. Its structure is made up of collagen and elastin fibers, which are combined into a thick glycoprotein matrix filled with hyaluronic acid and proteoglycans. Fascia serves to transfer force from muscles to the skeleton, and it also engages in mechanoreception. Fibroblasts and specific sensory cells found in its layers respond to changes in shape, triggering the production of cytokines and growth factors that initiate tissue repair after injuries. Under conditions of chronic overload, the fascial network thickens, disrupting the smooth movement between its layers and resulting in pain, fibrosis, or contractures. Therapies performed by hand, such as myofascial release, are designed to re-establish fiber mobility and regulate the hydration of glycosaminoglycans. Emerging research suggests that fascia is connected to the autonomic nervous system and has the capacity to transmit pain signals, which can lead to amplified muscle spasms throughout the body. Therefore, fascia is not simply a covering for organs, but an active sensory organ and a guardian of the body's mechanical stability.
Fact 69th. The mesentery, or mesentery, is an organ that has recently been recognized anew. It functions as the link between the small intestine and the posterior abdominal wall. The mesentery is composed of two peritoneal layers, with blood vessels, lymphatic vessels, and nerves situated between them. It secures the intestinal loops while also being flexible enough for peristalsis. The mesentery is involved in immune surveillance. Lymphatic follicles within its folds filter lymph and trap pathogens. Additionally, mesenteric tissue secretes adipocones and cytokines, which are messenger molecules that impact metabolism and inflammation throughout the body. In diseases like Crohn's disease, mesenteric inflammation worsens the condition, and fat deposits in it, known as mesenteric fat, act as a marker for the severity of the pathology. Surgeons report that preserving the mesentery's continuity after intestinal surgery decreases the risk of postoperative adhesions and bowel obstruction. Consequently, the mesentery is not simply a suspender of the intestine, but an integrated system for delivery, protection, and inter-organ communication.
Fact 70. The peritoneum is a serous membrane that lines the abdominal cavity and covers the internal organs. It is composed of two layers: the parietal layer, which is affixed to the abdominal walls, and the visceral layer, which snugly encases the organs. Situated between them is the peritoneal cavity, containing several milliliters of lubricating fluid. This fluid, a plasma with added hyaluronate, serves to diminish friction during the motion of internal structures. The peritoneum also serves a barrier function. In instances of infection, it swiftly transports macrophages and leukocytes to the inflammation's focus, forming fibrinous films that contain the site and impede the spread of peritonitis. Additionally, transperitoneal metabolism is facilitated by the peritoneum. During peritoneal dialysis, the solution for metabolic exchange is introduced precisely here, enabling the clearance of toxins and excess fluid. In cases of chronic inflammation, termed peritonitis, adhesions develop, restricting the mobility of intestinal loops. Within gynecology, the assessment of the peritoneal surface yields insights into fertility. The vascular network's density, alongside the presence of adhesions and scar tissue, influences the patency of the uterine tubes. Consequently, the peritoneum is not simply a covering, but a dynamic medium that facilitates reduced friction, protection, and metabolic exchange within the abdominal cavity.
Fact 71. Synovial fluid, or synovium, functions not merely as a lubricant, but as an intricate system for shock absorption, nourishment, and immune oversight, enabling the smooth, silent motion of our limbs. It is generated by a distinct layer of cells within the joint capsule's inner lining, synoviocytes of type A and B. Type A cells operate as macrophages, clearing away tissue debris and microorganisms. Type B cells produce hyaluronate, a long-chain polyuronic acid with a molecular weight up to 10 million Daltons, which is crucial for the fluid's viscosity and elasticity. Under normal conditions, the hyaluronate concentration is between 2 and 4 grams per liter, leading to nonlinear rheological properties. At low stress levels, synovium behaves like an elastomer, storing and returning energy, while at high stress levels, it acts like a paste, distributing pressure uniformly across the joint surface. Several hundred milliliters of this viscous, clear fluid are replenished daily through diffusion from the capsule's vascular network and filtration from blood plasma. It also contains essential proteins, including albumin, hyaluronidase, and lubricants, fragments of glycoproteins that reduce friction at the molecular scale. When this equilibrium is disrupted, such as in cases of arthritis, the hyaluronate concentration is halved, and the concentration of low molecular breakdown products increases, diminishing the joint's ability to withstand mechanical forces and shear stresses. During the 2020s, intra-articular biorevitalization techniques were developed, involving the administration of high molecular hyaluronates, stem cells, or growth factors to stimulate synoviocytes towards repair. Studies demonstrate that 6 months after a series of 3 injections, the joint's tissue begins to produce hyaluronate with a molecular weight nearly identical to that of the natural substance. Therefore, synovium is not just a lubricating substance, but a living organ that regulates movement quality, serves as a nutrient source for chondrocytes, and acts as a barrier against inflammation. Without it, any joint movement, such as bending or straightening, would be comparable to the operation of unlubricated gears, noisy, causing wear on interfaces, and resulting in pain.
Fact 72. Blood type is not merely a set of tables for transfusions, but a record of thousands of years of adaptation to infections, food, and migrations. The ABO system is determined by the presence of oligosaccharide antigens on the surface of red blood cells, A, N-acetylgalactosamine, B, galactose, or a combination AB, or the absence of a marker, O. These markers are encoded by alleles of the ABO gene on chromosome 9, where an insertion-deletion mutation results in an inactive enzyme for group O. Additionally, the Rh factor, Rh, is defined by the D protein on the red blood cell membrane, positive D+ when present, negative D- when absent. The evolution of group O is linked to resistance against malaria and dysentery. Carriers of the O allele experience a reduced risk of severe Plasmodium falciparum malaria, while group A is associated with increased susceptibility to cholera. The Rh negative factor exhibits geographical variation. In Europe, its prevalence reaches 15%, whereas in Asia and Africa, it barely exceeds 1%. This could reflect selection pressures from epidemics or ancient genetic events. In clinical practice, Rh factor incompatibility between an Rh negative mother, Rh-, and an Rh positive fetus, Rh+, can result in hemolytic disease of the newborn. During the first Rh-positive pregnancy, maternal sensitization is usually unnoticeable, but in subsequent pregnancies, her immune system produces IgG antibodies that can cross the placental barrier and destroy fetal red blood cells. Modern preventive measures, such as administering anti-Rh immunoglobulin at 28 weeks and after birth, have completely eliminated this cause of perinatal mortality. Consequently, blood type is more than just markers for transfusions. It is a key to understanding immunity, migrations, and the historical interplay between humans and pathogens. Fact 73rd. Genetic mosaicism and chimerism demonstrate that a single organism can contain varied genetic lines, originating from errors in cell division or the merging of embryos. Mosaicism involves a situation where some cells have one mutation and other cells have a different mutation due to changes that occur after the zygote is formed. For instance, port wine stain, a condition involving abnormal blood vessels in the skin, is caused by an activating GNAQ mutation that arises early in embryonic development and affects only a portion of the vascular cells. This localized genetic change results in a reddish hue and a distinctive pattern on the skin, while other tissues maintain their standard genetic makeup. Chimerism occurs when two zygotes combine to form a single early embryo, and the organism develops from the cells of both original zygotes. In humans, instances of mismatched genetic markers have been documented in bone marrow transplant recipients, where the patient gains the genetic characteristics of the donor. An even more remarkable example includes individuals known as two-hearted. In cases of complete chimerism, some people possess two distinct blood types which are detected in medical tests as both Group O and Group A simultaneously. Mosaicism can impact the clinical presentation of genetic diseases. In McCune-Albright syndrome, a mutation in the GNAS gene within cells leads to an overproduction of parathyroid hormone, resulting in polyostotic fibrous dysplasia of the bones, while other cells remain unaffected. In the field of oncology, mosaicism provides an explanation for the development of various tumor cell populations that exhibit different levels of sensitivity to chemotherapy. Consequently, a single individual is not always a genetically uniform or solid entity. Regions with differing DNA can exist within us, influencing the development, diagnosis, and treatment of several diseases.
Fact 74th. Fetal microchimerism describes the phenomenon where cells from a fetus migrate across the placenta and stay in the mother's tissues for decades, creating a living memory of the pregnancy. These cells, which are pluripotent, can be found in the liver, lungs, skin, heart muscle, and even the thyroid gland. Research shows that in the mother's heart after childbirth, fetal stem cells contribute to repairing damage following a myocardial infarction, differing from the mother's own cells by their HLA alleles. Yet, microchimerism can serve a dual purpose. On one hand, in conditions such as rheumatoid arthritis and systemic sclerosis, the presence of fetal cells is linked to increased autoimmune reactions, where the mother's immune system mistakenly attacks her own tissues, perceiving the fetal cells as foreign.
On the other hand, in several experimental settings, fetal mesenchymal cells have demonstrated the ability to suppress inflammation by decreasing the secretion of pro-inflammatory cytokines like TNF-alpha and IL-6, potentially paving the way for new therapeutic strategies. It has been observed that these cells can persist in the mother's body for over 40 years after giving birth, suggesting their capacity for self-preservation and division. The mechanisms responsible for their retention are not yet clear, but it is believed that local stem cell niches and regulation through growth factors are involved. Consequently, microchimerism is not simply a biological curiosity, but a tangible link between generations, where the fetus leaves a biological imprint in the mother's body that can participate in regeneration, immune dialogue, and possibly impact health decades down the line.
Fact 75th. Cerebrospinal fluid is a transparent, colorless fluid that circulates within the skull and spinal canal. The total volume is approximately 150 milliliters. It is produced by ependymal cells in the brain's ventricular vascular plexuses at a rate of about 500 milliliters daily. A large portion of it returns to the bloodstream through arachnoid granulations. Its consistency is similar to diluted plasma with low protein, but it maintains a vital balance of sodium, potassium, and chloride ions. Its primary function is buffering. It maintains stable pressure within the enclosed cranial space and protects the brain from mechanical jolts during head movements. Each heartbeat transmits a pulse pressure wave to the brain's blood vessels, which is then smoothed by fluid being transferred to the spinal canal. A secondary but equally important task is clearing metabolic waste. Neuronal byproducts such as excess glutamate and surplus potassium are carried by the CSF flow into the blood, along with traces of neuropeptides and signaling molecules. Disruptions in fluid circulation can lead to hydrocephalus. If absorption is impaired or the ventricular system is blocked, fluid accumulates, increasing intracranial pressure and causing cortical structure atrophy. In clinical settings, pressure measurement via lumbar puncture and CSF analysis are used to diagnose infections, meningitis, hemorrhages, and demyelinating diseases. Thus, cerebrospinal fluid is not just a shock absorber, but a dynamic homeostatic flow that provides nutrition, cleansing, and protection for the central nervous system continuously. Fact 76th. The meninges are three successive layers that envelop the brain and spinal cord: the dura, arachnoid, and pia mater. The dura mater is a robust fibrous sac with two layers. The outer layer is firmly attached to the inner cranial surface, and the inner layer forms the dural sinuses which collect venous blood. The arachnoid mater is positioned beneath it, supported by elastic trabeculae, with a thin fluid layer in the subdural space between them. The pia mater closely follows the brain's surface, mirroring all its folds. Together with the brain, it creates the subarachnoid space, where cerebrospinal fluid circulates. This system of trabeculae not only suspends the brain, but also serves as a conduit for blood vessels and nerve fibers entering deeper structures. When inflammation, meningitis, or bleeding, subdural hematoma occurs, the fluid between the meninges changes in transparency, pressure, and composition. These changes are immediately evident as headaches, neck stiffness, and altered consciousness. In neurosurgery, opening the dura mater, a procedure called craniotomy, provides access to pathological sites. However, it necessitates a specific technique to avoid damaging the subarachnoid trabeculae and to prevent air embolism. Therefore, the meninges function not just as protective coverings, but as a triad that provides physical strength, vascular drainage, and pathways for the circulation of vital fluid within the central nervous system.
Fact 77th. Lymph nodes are small oval filters found throughout the lymphatic system, with up to 600 in an adult body. Encased in a fibrous capsule and receiving lymph via afferent lymphatic vessels, these nodes contain immune cells. B lymphocytes in the cortical layer create primary follicles, while T lymphocytes in the paracortical zone provide cellular immunity.
Macrophages and dendritic cells patrol the sinuses, consuming macroorganisms and presenting antigens to lymphocytes. Lymph passing through a node is cleaned of foreign particles and cells. Within the follicles, in the fluorescent sphere, B cells are duplicated and matured, generating highly specific antibodies. After activation, lymphocytes exit through efferent vessels and spread throughout the body, enhancing its defenses. During infection, nodes close to the site, such as inguinal nodes for a foot wound or cervical nodes for tonsillitis, enlarge and become painful, signaling an active immune response. Conversely, in lymphomas, nodes grow without invading tissues and without pain, making a biopsy necessary for an accurate diagnosis. Thus, lymph nodes are not just beads in the lymph flow, but are miniature training centers, antibody factories, and checkpoints where the distinction between self and non-self is made daily in the endless stream of lymphatic fluid. Fact 78. Neutrophils are the most numerous of the blood's white blood cells, comprising 60% of the total leukocyte count. They serve as the first responders to sites of inflammation. Their origin is in the bone marrow from myeloid precursor cells, which undergo myoblast and promyocyte stages before mature granulocytes enter the bloodstream. Their cytoplasm houses hundreds of granules of two categories: azurophilic granules containing defensins and myeloperoxidase for oxidative bacterial killing, and specific granules containing lysozyme and lactoferrin for bacterial lysis. Upon encountering chemoattractants, neutrophils expedite their migration to the inflammatory focus by passing through the endothelium into tissues. Here, they capture pathogens via phagocytosis, forming a phagosome, and destroy them through an oxidative burst, utilizing reactive oxygen species. Under normal conditions, their lifespan in tissues does not exceed 2 days, after which they die, forming pus. In cases of chronic inflammation, the body can become overloaded with neutrophils, leading to the accumulation of toxins and damage to surrounding tissue. Consequently, neutrophils are not merely the weaponry of immunity, but a meticulously engineered biochemical mechanism, from their production in the bone marrow to their programmed death at the site of infection, where each granule functions as a warhead with a specific mission to safeguard the body. Fact 79th. The vestibular apparatus is an elegant mechanism for balance situated within the temporal bones, responsible for our spatial orientation. It has two main components, a set of semicircular canals and two bulges called the utriculus and the sacculus. Each of the three semicircular canals is aligned in its own plane, frontal, sagittal, and horizontal, and contains clear endolymph. As the head rotates, the fluid lags due to inertia, causing the elastic cupula, a gel-like covering over sensitive hair cells, to deform. This deformation triggers the generation of an electrical signal. The vestibular nerve carries this signal to the brainstem, where it is integrated with data from the eyes and proprioceptors, resulting in the perception of rotation or inclination. The utriculus and sacculus house otolithic membranes, which are thin plates embedded with calcium carbonate crystals, otoliths. When linear acceleration occurs or the head is tilted, these membranes shift, applying pressure to the hair cell cilia and transmitting a signal to the brain indicating vertical displacement. This mechanism facilitates the stabilization of gaze on a fixed point during motion, the vestibulo-ocular reflex, and regulates muscle tone for maintaining posture and locomotion. Inflammation of the vestibular nerve, known as labyrinthitis, leads to sideways instability, nausea, and nystagmus. For astronauts in zero gravity, the vestibular system lacks familiar gravitational cues, necessitating days for adjustment. It has been discovered that in weightlessness, otoliths disperse, and the cupula responds to any movement as if it were rotation, causing what is termed space sickness. Therefore, a system designed for Earth can instantaneously communicate millimeter-scale changes in body position to the brain, and it is this system that provides us with our sense of balance in any position. Fact 80. Proprioception in muscles and joints serves as an invisible navigation mechanism, allowing us to walk without looking down and to handle small objects while maintaining a connection between vision and action. The key receptors are muscle spindles and Golgi tendon organs. A muscle spindle is a capsule of connective tissue outgrowths placed parallel to muscle fibers. Inside are specialized intrafusal fibers with receptor endings. When a muscle stretches, the spindle stretches too, and its sensory endings generate rapid impulses informing the spinal cord about the muscle's length. At the same time, gamma motor neurons adjust the spindle sensitivity by changing the tone of intrafusal fibers. The Golgi tendon organ is located where the muscle meets the tendon and responds to tension. Under heavy loads, the capsule's collagen fibers squeeze the receptor endings, sending an inhibitory signal to the muscle's motor neurons to prevent tearing. These two systems work together. Spindles monitor length, and Golgi organs monitor tension. Signals via IA and IB afferents go to the spinal cord's dorsal horns, where they directly or through interneurons affect alpha motor neuron activity. This automatic process means that during walking, muscles turn on and off without conscious commands, and a flexor reflex is triggered automatically when an unexpected obstacle is met. Problems with proprioception, like those in diabetic neuropathy or Ehlers-Danlos syndrome, lead to unstable joints, frequent injuries, and a loss of the body sense in space. Therefore, it's not just vision and balance, but also internal sensors deep in muscles and tendons that create a constant map of our position and movement.
Fact 81. The heart's conductive system, an independent rhythm generator and contraction distributor, is composed of the sinoatrial node, atrioventricular node, bundle of His, and Purkinje fibers. The sinoatrial node, Keith-Flack node, is a group of pacemaker cells situated on the right atrial wall near the superior vena cava's entry point. Spontaneous membrane depolarization occurs in these cells due to a leaky ion channel current, which dictates the contraction frequency, typically 60 to 100 beats per minute for adults. The impulse propagates through the atrial muscle, causing atrial contraction and subsequent ventricular filling. The signal then arrives at the atrioventricular node, where a brief delay occurs, ensuring a smooth transition from atrial contraction to ventricular contraction. This delay is caused by a specialized connective tissue barrier and the slow conduction velocity of the AV node cells. From there, the impulse travels via the bundle of His, which divides into right and left branches extending along the interventricular septum. The Purkinje fibers, extending into the ventricular myocardium, spread excitation instantaneously, enabling coordinated contraction that pushes blood into the major and minor circulatory systems. Issues with the Keith-Flack node can lead to sinus arrhythmia. AV node block can cause bradycardia or complete blockage, and premature Purkinje fiber contractions can result in ventricular extrasystolia. Modern pacemakers imitate the sinus node's activity, and the ablation of diseased areas corrects atrial fibrillation. Therefore, every second of existence is managed by a minute network of conducting cells, functioning autonomously but guaranteeing the precision and synchronization of cardiac mechanics.
Fact 82. The skin of humans is inhabited by a vast microbial community referred to as the skin microbiome. It encompasses hundreds of species of bacteria, fungi, and viruses, all interacting with each other and with our immune system. Distinct ecosystems are established on various body locations: the face, scalp, armpits, palms, and soles of the feet. In areas with higher oil production, such as the forehead and chest, propionibacteria are dominant. They break down lipids from the sebaceous glands, establishing an acidic environment. In moist folds, like the groin and armpits, Corynebacteria and Staphylococci are found. These microbes participate in generating body odor by metabolizing the secretions from apocrine glands. Between the toes, in moist conditions, yeast-like Malassezia are most common, while the hands are populated by Streptococcus and Acinetobacter. These microorganisms form biofilms, which act as a protective shield against harmful pathogens and contribute to the skin's barrier integrity. They also stimulate the production of antimicrobial peptides, specifically defensins and cathelicidins.
However, when the microbiome's equilibrium is disturbed, dysbiosis, it can lead to skin conditions such as dermatitis, acne, psoriasis, and eczema. A notable example is atopic dermatitis, where reduced bacterial diversity is observed and Staphylococcus aureus takes over, releasing toxins that worsen inflammation. Promising new therapeutic strategies, including probiotic and prebiotic creams and the transplantation of beneficial microbes, are being explored for treating skin diseases by modulating the body's own microflora. In essence, our skin is not a sterile covering, but a sophisticated, multi-level ecosystem shield where billions of bacterial and fungal populations offer protection and manage communication with the host cells. Fact 83rd. The pituitary gland, also called the brain's appendage, is a tiny gland weighing about 1.5 grams, but it directs all other endocrine organs. It is located within the sella turcica of the sphenoid bone, hanging from the hypothalamus by a thin stalk that delivers regulating hormones. The pituitary has two parts, the anterior lobe, adenohypophysis, and the posterior lobe, neurohypophysis. The adenohypophysis makes and releases 6 main hormones: somatotropin, growth hormone, prolactin, adrenocorticotropic hormone, ACTH, thyrotropic hormone, TSH, follicle-stimulating hormone, FSH, and luteinizing hormone, LH. Each hormone is in charge of a specific pathway. TSH manages the thyroid gland, ACTH manages the adrenal cortex, FSH and LH manage reproductive activities, somatotropin manages tissue growth and metabolism, and prolactin manages milk production and immune system functions. The neurohypophysis keeps and releases 2 neurohormones made in the hypothalamus's centers into the blood when needed: vasopressin, which controls the water and salt balance in the kidneys and blood pressure, and oxytocin, which starts uterus contractions during birth and helps with nursing. The pituitary works by releasing factors from the hypothalamus in pulses, which go to the adenohypophysis through a special blood vessel system. Information about the levels of 3 main hormones helps to fine-tune how much is released. Problems with the pituitary, like tumors, low pituitary function, or too much or too little hormone release, cause many different issues with growth, metabolism, reproduction, and the balance of water and salts, making this gland the lead conductor of the body's hormone system. Fact 84th. The hypothalamus, a section of the diencephalon, is comparable in size to a small almond, but exerts unparalleled regulatory influence. It oversees body temperature, hunger and satiety signals, thirst, the cycle of sleep and wakefulness, stress responses, sexual behavior, and thermoregulation. The hypothalamus houses neurons that synthesize over 10 neuropeptides. These include neuropeptide Y, which stimulates appetite, corticotropin-releasing hormone, which activates the hypothalamus-pituitary-adrenal axis, and somatostatin and dopamine, which inhibit the secretion of growth hormone and prolactin, respectively. It receives sensory input from the body's internal milieu, blood temperature, osmolarity, glucose, and hormone levels, as well as external stimuli from the retina and the limbic system. Via the pituitary stalk, it precisely controls the anterior pituitary, with each signal from releasing and inhibiting factors modulating the secretion of the 6 anterior pituitary hormones. In parallel, axonal projections to the posterior pituitary facilitate the release of vasopressin and oxytocin. Injury or tumors affecting the hypothalamus can cause thermoregulatory issues, uncontrolled appetite or thirst, and disruptions in sleep and behavior. Managing deficiency syndromes requires hormone replacement therapy and in-depth neuroendocrine monitoring. The hypothalamus serves as a neuroendocrine switchboard, integrating all primary pathways for homeostasis and adaptation to environmental shifts. Fact 85th. The vegetative or autonomic nervous system is split into sympathetic and parasympathetic divisions. These divisions frequently operate antagonistically, yet in a balanced state, they preserve internal parameters such as heart rate, vascular tone, breathing, digestion, and thermoregulation.
The sympathetic system, originating from the thoracic and lumbar spinal cord regions, becomes active during fight or flight stress situations. During this activation, norepinephrine enhance cardiac output, constrict peripheral blood vessels, dilate bronchioles, and decrease intestinal peristalsis. The parasympathetic system, with its central points in the brainstem, specifically the vagal and sacral nuclei, governs the rest and digest functions. Acetylcholine in this context lowers heart rate, promotes the secretion of digestive fluids, increases the tone of the vagus nerve, and stimulates intestinal movement. Both systems link to organs through ganglia. The sympathetic system uses paravertebral chains, while the parasympathetic system uses terminal ganglia situated near the organs. An imbalance, referred to as sympathic atonia or vagatonia, can manifest as hypertension, arrhythmias, gastrointestinal disturbances, disruptions in heat balance, and may lead to vegetative vascular dystonia. Methods for correction involve pharmacological blockade of alpha and beta adrenergic receptors, modulation of cholinergic activity, and instruction in breathing techniques to activate the vagus nerve. The autonomic nervous system serves as an imperceptible regulatory spectrum that maintains the internal environment in a state of dynamic equilibrium, responding instantaneously to any challenge.
Fact 86. Skeletal muscle fibers are classified into three main categories, each responsible for specific functions: slow oxidative, type I, fast oxidative glycolytic, type 2A, and fast glycolytic, type 2B. Type 1 fibers are characterized by a high concentration of mitochondria and myoglobin, good vascularization, and reliance on aerobic metabolism, making them resistant to fatigue and crucial for postural support and endurance. Type 2A fibers have a moderate amount of mitochondria and can operate using both aerobic and anaerobic pathways, providing intermediate contraction speed and endurance levels. The most explosive are type 2B fibers, which have few mitochondria and capillaries. Their anaerobic glycolysis allows for a rapid but short-lived power output, resulting in lactate accumulation and quick fatigue. The proportion of these fiber types within an individual is genetically determined, but training can alter these ratios. Endurance training increases the proportion of oxidative fibers, while sprint training favors glycolytic fibers. Within a muscle, all fibers innervated by a single motor neuron are of the same type, forming motor units of different capacities. These units are activated in a specific order. Low-intensity activity recruits small motor units with type I fibers, and as the effort increases, larger units of type 2A and 2B are recruited. This principle of sequential recruitment ensures a smooth increase in force and efficient energy utilization. Understanding muscle fiber types is fundamental for optimizing sports performance, facilitating rehabilitation after injuries, and treating muscle weakness. Fact 87. The process of hemopoiesis, meaning the continuous renewal of blood cells, occurs within the red bone marrow. This process is mainly situated in flat bones, such as the sternum, pelvis, ribs, and skull. The entire blood supply of a person, roughly 5 liters, is completely regenerated on average every 70 days. Red blood cells survive for 120 days, platelets for 7 to 10 days, and white blood cells for periods ranging from a few hours to several days. The origin of this process lies in stem cells, which are the true ancestors, capable of both self-replication and differentiation. The choice of a specific developmental route is dictated by a mix of cytokines and hormones. Erythropoietin, produced by the kidneys, stimulates the generation of red blood cells. Thrombopoietin, produced by the liver, stimulates the generation of platelets. Interleukins and colony-stimulating factor stimulate the generation of white blood cells. Cells undergo a strict selection at every stage. Apoptosis eliminates defective or excessively active cells, while the properly formed ones are released into the blood. When blood is lost, erythropoietin levels rise instantly, leading the bone marrow to double its red blood cell production. In cases of infection, the system reorients its priority towards white blood cells.
The comprehension of hemopoiesis's molecular mechanisms has facilitated the creation of bone marrow transplantation for treating leukemias and the application of stimulating factors in vitro, thereby saving the lives of tens of thousands of patients annually.
Fact 88. Brain metabolism operates like an energy atom. Each gram of brain tissue consumes roughly 5 milliliters of oxygen per minute. The central nervous system as a whole uses close to 20% of the body's total oxygen and glucose. Neurons lack glycogen stores, making them dependent on a constant blood supply. A reduction in blood flow of just 10% leads to cognitive impairments within seconds. Blood flows in brain capillaries at about half the speed seen in other tissues, ensuring better oxygen and carbon dioxide exchange. Astrocytes surround neurons with a lateral cuff, absorbing excess glutamate and potassium ions. They process these substances and then supply neurons with lactate as an alternative fuel source during periods of high activity. Microglia patrol the extracellular space, ingesting small fragments and maintaining homeostasis. The balance of the brain's homeostatic processes is determined by the barrier functions of the endothelium, the blood-brain barrier, the activity of the glymphatic system, and the precise regulation of neuromodulators such as acetylcholine, dopamine, GABA, and serotonin. Disruptions in metabolism, including vascular diseases, hypoglycemia, and hypoxia, initiate inflammatory cascades that can cause neurodegeneration. The study of brain metabolism paved the way for stroke therapy, where restoring blood flow to a vessel, recanalization, within the first few hours can recover up to 50% of lost functions.
Fact 89th. The human body's thermal regulation is a complex equilibrium between heat creation and heat dissipation. When ambient temperatures fall, the hypothalamus's central thermoregulatory system activates two key processes, cutaneous vasoconstriction and shivering. Shivering, an involuntary and rhythmic muscle contraction, has the capacity to double the rate of heat generation. When body temperature rises, the body initiates sweating and cutaneous vasodilation to enhance heat loss through evaporation and convection. The effectiveness of sweating is contingent upon the density of eccrine glands, which can total up to 5 million across the body, and on the level of atmospheric humidity. Trained individuals experience earlier and more uniform sweat production, providing a defense against overheating during physical exertion. A central effect is also present. Compounds like pyrogens interact with hypothalamic receptors, increasing the body's set temperature, which is observed as fever during infections. Acclimatization to cold and heat environments leads to adjustments in the activation thresholds for thermal regulatory mechanisms. Under regular cold exposure, shivering begins at lower temperatures, and in hot weather, sweating is triggered earlier. Impairments in thermal regulation resulting from conditions such as hypothyroidism, diabetes, or damage to vegetative centers present substantial risks of heat stroke or hypothermia. Thus, over millions of years of evolutionary development, humans have succeeded in creating one of the most versatile and flexible protective systems.
Fact 90. The skin's sensory apparatus extends beyond mechanoreceptors, with thermoreceptors and nociceptors forming separate neural networks. The transmission of pain and temperature sensations is handled by thin, unmyelinated C fibers, operating at speeds up to 1 meter per second. Sharper, pricking pain is conveyed by faster, myelinated A-delta fibers, which conduct signals at speeds up to 20 meters per second. Ion channels for cold, TRPM8, and heat, TRPV1, are activated by temperature variations as small as a few degrees, covering a perceptual range from 4 to 48 degrees Celsius. Nociceptors, characterized as free nerve endings, respond to mechanical, thermal, and chemical stimuli. Upon tissue injury, they are activated by substances released from damaged cells, such as prostaglandins, serotonin, and bradykinin, relaying signals to the spinal cord. From there, these signals are routed to the thalamus and sensory cortex.
Within these areas, the experience of pain is processed, and the body's own pain-inhibiting systems, namely endorphins, enkephalins, and neuropeptide Y, are activated. These internal opiates reduce the conductivity of pain signals at the subcortical structures and reticular formation. This allows the organism to achieve a balance between initiating a protective response and maintaining the functionality of the affected area. Therefore, the skin functions not only as a protective barrier, but also as a sophisticated, multi-tiered organ of sensation and self-regulation, promptly alerting the brain to any danger and initiating defensive mechanisms.
Fact 91. The synapse is the foundation of neural communication, defined as the narrow gap between an axon terminal of one neuron and a dendrite of another. Inside the presynaptic terminal are vesicles loaded with neurotransmitters, which are messenger molecules like glutamate, gamma-aminobutyric acid, GABA, dopamine, serotonin, and acetylcholine. When an electrical impulse arrives at the axon, calcium channels open, allowing calcium ions to enter. This entry causes the vesicles to move to the membrane and merge, releasing their contents into the synaptic cleft. The released molecules spread through the 15 to 20 nanometer space and bind to specific receptors on the postsynaptic membrane, opening or closing ion channels, thereby either exciting or inhibiting the next neuron. After performing their function, neurotransmitters are cleared from the cleft via 3 routes: reuptake by transporters into the presynapse, breakdown by enzymes like acetylcholinesterase, and diffusion into surrounding tissues. A specific group, peptide neurotransmitters, have a longer action and can influence local networks by changing synapse sensitivity. Synaptic plasticity, the ability to modify transmission strength based on activation frequency and patterns, is the basis for learning and memory. Long-term potentiation, LTP, and long-term depression, LTD, are controlled by protein kinases and calcium-dependent pathways, leading to alterations in the number of receptors and the structure of dendritic spines.
Fact 92. The central nervous system is enclosed by a special region known as the ependymal complex of ventricular channels, through which cerebrospinal fluid circulates. The choroid plexuses, which are lined with ependymal cells and located in the lateral, third, and fourth ventricles, produce CSF, and its flow is managed by cisterns and channel connections. The main exchange of water and electrolytes between the blood and CSF is handled by osmoreceptors and the precise regulation of the sodium ion pump in the ependyma. When there is too much CSF production or a blockage in its passage, internal hydrocephalus occurs. This condition leads to increased pressure within the ventricles, causing them to enlarge and compress the brain's cortical structures, resulting in cognitive and motor impairments. Treatment for this involves inserting a shunt to redirect the fluid to the abdominal cavity. Changes in the composition of CSF are noted in the pathology of certain diseases that cause demyelination and neurodegeneration. Increased levels of protein, immune complexes, and oligoclonal bands suggest autoimmune processes and are actively used to diagnose multiple sclerosis.
Fact 93. Pulmonary circulation is the sole route characterized by low arterial pressure and minimal vascular resistance, thereby optimizing gas exchange in the lungs. The right ventricle of the heart propels venous blood into the pulmonary artery. This artery bifurcates into 2 main branches, subsequently dividing into segmental arteries, arterioles, and capillaries that encircle the alveoli. Within this area, the partial pressure of carbon dioxide in the blood is higher than in the alveolar air, facilitating its outward diffusion. Concurrently, oxygen from the air enters erythrocytes, binding to hemoglobin's heme. The logarithmic nature of the oxygen dissociation curve ensures that red blood cell saturation reaches 99% at normal alveolar PO2. Following saturation, the blood returns via the pulmonary veins to the left atrium, supplying the arterial system with oxygen. Cardiopulmonary diseases such as pulmonary hypertension or embolism can cause elevated resistance, leading to right ventricular failure, edema, and tissue hypoxia. Fact 94. The arterial wall is structured with three distinct layers: the intima, the media, and the adventitia. The intima, serving as the internal layer, is constructed from endothelial cells. These cells are responsible for producing nitric oxide and prostacyclins, which play a role in regulating the tone of smooth muscle cells and inhibiting thrombosis formation. The media, positioned as the middle layer, comprises smooth muscle cells and elastic fibers. These components are crucial for maintaining elasticity and enabling vasoconstriction and vasodilation, processes governed by the autonomic nervous system and hormonal influences. The adventitia, constituting the external layer, is composed of collagen fibers. This layer also houses nerve fibers and the vessels of the adventitial network, referred to as vasa vasorum, which provides sustenance to the artery wall itself. In cases of atherosclerosis, lipids and inflammatory cells infiltrate the intima, leading to the formation of plaques. These plaques constrict the vessel's lumen and can trigger thrombosis. As a compensatory mechanism, the media may undergo thickening to counteract elevated pressure. Contemporary therapeutic approaches encompass stenting, the targeted disintegration of plaques via ultrasound, and pharmacological interventions using statins. Statins are utilized to stabilize plaques and mitigate the risk of myocardial infarction and cerebrovascular accidents. Fact 95th. Telomeres, acting as protective caps on chromosome ends, are vital for cell aging and regeneration. Each DNA division cycle cannot fully replicate the terminal regions, and without fixes, chromosomes would shorten, leading to genetic information loss. The enzyme telomerase, containing reverse transcriptase and an RNA template, adds the T-tag-G tandem repeats at human chromosome ends. Telomerase is highly active in embryonic and stem cells, supporting their extended lifespan and division ability. With age, telomerase is deactivated in most somatic cells, and telomeres shorten by 200 to 300 nucleotides per cycle. When telomere length falls below a critical level, senescence or apoptosis is triggered. This genetic failsafe guards against uncontrolled division, oncogenesis, but limits tissue regeneration. Cancer cells show telomerase reactivation or alternative end lengthening mechanisms, enabling endless proliferation. Experiments modifying telomerase in mice extended lifespan by 10 to 15%, but also increased oncogenesis risk. Therefore, the balance between aging and cancer depends on fine control of telomere length, the cellular timekeeper. Fact 96. Autophagy, described as cellular self-eating, is a crucial mechanism for cellular cleansing and adaptation to stress. When nutrient supply is low or organelles are damaged, the mTOR signaling pathway is activated. Inhibiting this pathway initiates the formation of a phagosome, a vesicle with a double membrane. This phagosome collects defective mitochondria, excess protein aggregates, or pathogenic bacteria. The phagosome then fuses with a lysosome, forming an autophagolysosome. Within this structure, hydrolytic enzymes break down the enclosed material into amino acids, lipids, and carbohydrates. These breakdown products are returned to the cytoplasm, serving as fuel and building blocks. Autophagy contributes to maintaining the stable state of neurons, blood cells, and liver tissues by removing aged organelles and preventing the accumulation of toxic aggregates. A deficit in autophagy is linked to diseases such as Alzheimer's, Parkinson's, and obesity. Conversely, overactive autophagy can cause cell death in cases of ischemia. Experiments with mice showed that activating autophagy, either through limited feeding or pharmacologically with rapamycin, extended their lifespan by 15 to 20% and protected them from age-related changes. This implies that a cell is not just a passive storage facility, but a dynamic factory for self-processing, with autophagy acting as the main quality control and energy source during difficult times. Fact 97th. The hemostasis system unites vascular response, platelet aggregation, and the coagulation cascade for prompt bleeding stoppage. Endothelial damage triggers the release of thromboxane A2 and thromboglobulin alongside collagen exposure. Platelets adhere to the subendothelium via von Willebrand factor, change form, and release adenosine diphosphate, serotonin, and thromboxane, intensifying aggregation. In parallel, the clotting cascade activates. With a thrombin tramway, endotachygen, tran, and factor 12 present, factors XI, I, and 8 are sequentially activated. The XAIA complex, formed with factor X, generates a proconvertase. Within the foliate stream, the proconvertase converts factor X to XA. Combined with factor V, it forms prothrombinase, which catalyzes thrombin formation from proconvertin. Thrombin, besides converting fibrinogen to fibrin, activates factor 13, stabilizing the fibrin-fiber network, and enhances positive feedback by activating factors V and 8. This intricate biochemical process rapidly converts liquid plasma into a gel, sealing the wound. Subsequently, macrophages and fibroblasts undertake tissue repair. Deficiencies at any level, hemophilia A from factor 8 deficiency, B from factor I deficiency, or thrombin deficiency, result in spontaneous bleeding. Excessive activation leads to thrombosis, strokes, and heart attacks. Hemostasis is not merely a response to injury, but a precise biochemical symphony, requiring each element to perform at the designated moment.
Fact 98. The neurosecretory activity of the hypothalamus and adenohypophysis creates a singular axis, termed the hypothalamic pituitary stalk. Neurons located in the suprachiasmatic and paraventricular nuclei synthesize releasing factors. These factors are transported to the adenohypophysis via the pituitary's portal vascular network. Within the adenohypophysis, releasing hormones specifically either promote or inhibit the synthesis of tropic hormones, such as ACTH, TSH, FSH, LH, somatotropin, and prolactin. Following this, effector hormones released from the adenohypophysis circulate in the blood to influence peripheral endocrine glands. This neural and vascular connection generates pulsatile secretion patterns. For instance, ACTH secretion occurs in pulses once per hour and TSH pulses twice a day. This pulsatility facilitates adaptable responses to seasonal, daily, and stress-related environmental changes. In cases of nervous system diseases, damage to this system results in neuroendocrine syndromes. For example, adenohypophyseal tumors can cause an increase in prolactin levels, leading to galactorrhea, amenorrhea, while hypothalamic lesions can result in diabetes insipidus, marked by the inappropriate excretion of vasopressin. Consequently, neurosecretion acts not merely as a hormone delivery system, but as a sophisticated rhythm generator, integrating exchange signals and high-priority commands within a single venous channel. Fact 99. The liver functions as the body's central biochemical laboratory where the detoxification of numerous compounds occurs thanks to the cytochrome P450 system. This multi-enzyme complex consists of over 40 isoforms, each specializing in the transformation of particular substances, medications, hormones, and xenobiotics. In the first phase of biotransformation, P450 enzymes oxidize substrates by introducing a polar group, a hydroxyl, carboxyl, or amino group, into the molecule. Then, in the second phase, the polarized metabolite is conjugated with glucuronic acid, sulfate, or glutathione, with the involvement of corresponding transferases, making it water-soluble and allowing for its easy excretion in bile or urine. The activity of a specific CYP isoform is dependent on genetic polymorphism. In some individuals, CYP2D6 catalyzes up to 80% of all metabolic transformations, while in others, its functions are partially or completely lost due to allele deletion, affecting the pharmacokinetics of antidepressants, beta blockers, and opioids. In addition to genetics, P450 expression is regulated by inflammatory cytokines. For instance, interleukin-6 reduces the activity of most CYPs. Hormones, glucocorticoids enhance CYP3A4. And dietary components, grapefruit juice inhibits CYP3A4 in the intestinal wall. In cases of poison or drug overdose, the liver can induce a significant increase in the rough endoplasmic reticulum, where P450 isoforms are located, thereby increasing detoxification power. However, chronic exposure can lead to induced hepatotoxicity. Reactive intermediates are formed, which bind to hepatocyte proteins, initiate oxidative stress, and cause apoptosis. Conversely, P450 inhibitors, such as ketoconazole or erythromycin, can lead to drug accumulation and toxic reactions. Thus, the cytochrome P450 system of liver cells is not merely a liver detoxification station, but a highly precise complex that balances the safe elimination of foreign substances with the risk of reactive metabolite formation, and the efficacy and safety of drug therapy largely depend on its operation. The endocannabinoid system is a universal regulator of homeostasis. It operates through endogenous cannabinoids, anandamide, 2-arachidonyl glycerol, CB1 and CB2 receptors, and enzymes for synthesis and degradation. CB1 receptors are concentrated in the brain in areas like the hippocampus, basal ganglia, and cortex, and they regulate memory, mood, pain sensitivity, and motor coordination. CB2 receptors are mainly found in immune cells and are involved in modulating inflammation and immune responses. Anandamide is synthesized in the postsynaptic membrane from phosphatidylinositol by N-acylphosphatidylethanolamin hydrolase. It is released into the synaptic cleft and acts retrogradely, binding to CB1 on the presynaptic membrane, which reduces the release of excitatory neurotransmitters, glutamate, or inhibitory ones, GABA, thereby modulating neuronal excitability and plasticity. 2-arachidonyl glycerol is formed from phosphatidylinositol via phospholipase C and diacylglycerol lipase. It acts similarly to anandamide, but persists longer and is more resistant to hydrolysis by monoacylglycerol lipase. Anandamide is rapidly degraded by fatty acid amide hydrolase, ensuring precise temporal regulation of signaling. The endocannabinoid system also regulates appetite by influencing the hypothalamus. CB1 activation in the hypothalamus stimulates hunger and reduces energy expenditure. Blocking these receptors, as seen in Remonabant experiments, led to weight loss by decreasing calorie intake. In the brain, the system is also involved in reward mechanisms and pain threshold regulation. Endocannabinoids reduce pain perception and promote positive affect. Therefore, the endocannabinoid system functions as a flexible sensor and corrector of many physiological processes, from immune response to cognitive functions, maintaining a fine balance between excitability and protection, hunger and satiety, and pain and comfort. Its disruption is associated with neurological, psychiatric, and metabolic disorders. Modulating CB1 and CB2 receptors opens pathways to new therapies for a wide range of diseases.